and natural gas technologies. So welcome you all to this day. Today will be the last day for this event workshop, and I hope you all inquisitive minds take the points to be noted down for your competition, because we will surely meet for the competition. Before that, this is the workshop that we are ready with, and yeah, let us go ahead. So with our first session, today to kick off today's session, we are honored to have Dr. Ajit Babu, an industrial expert with extensive experience at ARAI. He is an R&D expert specializing in lithium-ion battery engineering with 13 years of experience. He is a published researcher with 22 publications, one granted patent, and has earned accolades like the Best Executive Award at ARAI Pune, a certified intellectual property patent agent. He is also recognized for his expertise in metal forming technology. So, first session of today we'll be having is of storage system, the cylinder specification for natural gas, which is for the natural gas storage, ensuring safety and compliance with the industry standards. With that, subsequently we'll be having the another session of Dr. Ajit Babu only, and this is for the regulatory framework and safety requirements for H2 HCNG storage. And this will be for the critical safety standards and the regulations necessary for the storage and handling of the hydrogen and HCNG, ensuring both safety and compliance. To all the participants, whatever doubt you're having throughout the session, you can get it on the chat box. We'll take your doubts in the Q&A session. So here we begin.
Thank you, Naini. So shall I start my presentation?
Yes, sir. Yes, sir.
Yeah. Can you see my screen? Can someone confirm, please?
Yes, we are able to.
Yeah, thank you. So first of all, I would like to thank the leadership team at hBAJA for giving an opportunity to talk to you all through this wonderful platform. Important, a junction we are, that is the energy transition, and Baha becomes one of the key pillar in developing new technologies or holding the torch of implementing new technologies on the ground. So hBAJA is something really exciting because it has now in addition to electric Baha, the hydrogen being one of the future fuel being utilized in this competition. And you being the founding student participants of this wonderful event. So I'm really glad to speak to you all about this hBAJA, the hydrogen as such, and it is an evolving field, not as old as even the electric mobility. Hydrogen is just evolving, and we are all learning together in this journey. So today I'm going to talk about the storage, the gas storage system, the safety, the regulation aspect. So I had 2 lectures. I requested the team, and they gracefully agreed to merge both the presentations, because as such there is no boundary line. When we talk about testing, the regulation also comes into picture. So so this is a single presentation encompassing all the aspect to it. So I am Ajit Babu. I am having an experience of around 13 years in ARAI, and recently I have started my own entrepreneurship journey, and now I represent Good Life Mobility Private Limited, wherein we are working in the area of hydrogen mobility. So let's start the presentation, and I will be happy to answer all your queries. So this is a very recent news. I'm sure few have heard about it, or it may be new for some few people. So we all know that there is a conflict going on between Ukraine and Russia, and Ukraine is pushing the Russian forces, and they use multiple strategies like drone attack and so on. And one of the latest strategy what Ukraine used is to make an explosive, a cheap explosive from a wrecked Toyota car. So this Toyota car is the model is Mirai. So Mirai is a hydrogen car. So it uses hydrogen as a fuel. So they took this hydrogen fuel from the car. They converted it into explosive. So the weight of the tank, if you see from the report, is around 54 kg. So it's a very lightweight tank, and it was holding somewhere around 5 kg of hydrogen, and the pressure on the tank was around 690 bar or around 700 bar. So the tank was quite sturdy. It can withstand a very high pressure, even 22,500 feet underwater, as reported in the news. So the potential energy of the hydrogen inside the tank was very high. It's around per kg, it was around 33.6 watt hour, and on the totality, it was around 650 plus megajoules for the entire tank. So this, when it was converted into an equivalent to TNT explosive, it was equivalent to 160 kg of TNT, and this really dented the Russian forces, and I understand there was a retreat as well. So this is the kind of danger or the kind of safety precaution we need to take while dealing with hydrogen as a fuel. And the Toyota Mirai is the only commercially available car in the segment, and they have cleverly utilized this for a very not so good purpose. So this one news will tell you how important it is to understand the storage system, how it has to be dealt, what are the different testing need to be done, or what is the different regulation perspective, because tomorrow you will be handling gases. Gases could be hydrogen, or it could be combination of hydrogen. The way for this hBAJA you are combining with CNG, HCNG. So we will start from CNG to HCNG and then hydrogen. That is the transition we are expecting to happen. It will happen in the industry. So whatever with the gases, if hydrogen is there in the fuel system, it is dangerous, and it need to be dealt very safely. For that, we have to be aware of the different practices or different technology available worldwide. So for next an hour or so, I will be just deep diving on a multiple aspects of hydrogen. You can always, when I say hydrogen, you can also correlate that with HCNG as well, because you have around 18% of hydrogen in that. So this is the safety net which we need to follow in order to avoid this kind of situation while we driving any vehicle which has hydrogen as a fuel. So the entire industry, since there are multiple plants like steel plants also who are working on generating hydrogen. So Reliance has a vision of 111. It was told by Mr. Ambani some 2 years back of 1 decade, $1 and 1 kilo. So within a decade, 1 kilogram will cost only $1. That is the kind of vision steel plants have. So hydrogen will be generated in India. So it will be cheap. We will not to buy anything from outside. So import substitution will happen. Clean fuel will be there, and on a cost competitive rate. So considering that, already industry has started working a lot. So you can see hydrogen has two applications. One is the fuel cell, and then fuel cell powers the entire vehicle. And the second one is the hydrogen ICE, H2ICE, that is a internal combustion engine. So all the companies, you can see Toyota, Tata Motors, Leyland, Reliance, everyone are developing their own prototype. So in the journey of hydrogen, if you see, maybe the first stop will be H2ICE, that is converting an existing internal combustion engine and adapting to hydrogen as a fuel. And then maybe later we can also see fuel cell coming in for a commercial application. There are already few applications wherein fuel cell is used and mobility is happening with fuel cell as well. So it could be a H2 ICE or fuel cell, but whatever could be the power generation approach, we will require hydrogen as a fuel. We are going to talk about the uh, storage part of that hydrogen. So these are the H2Is being displayed by Cummins, companies like Cummins and Ashok Leyland and so on. And for the prototype vehicles which have been made by these companies, you can see big tanks. So these are all tanks from different prototypes, and you can see how they are connected, the pipings, the fittings, and somewhere the layout, everything you can see. These are all not car, these are all commercial vehicles. So when we say storage system, it is just not the cylinder. It also has all the valves to it, the fittings, the pipings, the pressure relief devices. So the entire fluid, controlling the fluids. So entire fluid control part of the hydrogen comprises the fuel delivery system. So we will start with some images. So I thought maybe I will just give you a flavor with in which automotive industry is heading, and tomorrow you will also be working in this kind of technology. Okay, so when we say storage solution, we have to really understand the basics. Then we can go into diving deeper. So when we say storage solution, then it could be different types of storage solution. So we call it type 1, type 2, type 3 and type 4. You can see here. So type 1 is a full metal cylinder. So there is no non-metal. So the vehicles what you are seeing in the road presently, the CNG vehicles being run, they all use type 1 cylinder. So it's purely completely 100% metal. But metal has some pros and some cons. So you can see the weight and cost here. So type 1 metal, let's say we have what the cost considering as 100 percentage, cost is around, weight is considered as 100 percentage, and then you can see how type 2, type 3, type 4 are reducing, and type 3 and type 4 if we consider 100%, how the cost varies for type 1 and type 2 is given in the table. So type 1 is less costly, maybe around 40% of the cost, and it is the heaviest part because it is purely metal. Metal means steel, so it is a steel cylinder. Then comes the type 2. Type 2 is like it has some carbon fiber to it. So some carbon fiber is wrapped on the side, the body only, the center portion. And the top and bottom, the dome are still open. So it is still having the load bearing is mainly done by the metal, but it has some carbon fiber to it to take few of the load and to compensate the pressure. So that is called type 2 cylinder. So as you can see from here, type 2, of course, the weight reduces because carbon fiber is introduced, of course, but the cost also increases because the cost of carbon fiber is very high. So now this was primarily to do some lightweighting on the cylinder part and to carry more gas. That was the objective of type 2. And then came type 3. Type 3, if you see, it's fully wrapped with carbon fiber. As you can see in the image, it is completely wrapped with carbon fiber, and of course there is a liner which is and still a metal part. So generally it is a aluminum liner. So there is a small aluminum liner which has all the valves and fittings, and then this aluminum liner is wrapped with carbon fiber. Here the carbon fiber takes good amount of load. So type 3 is mainly done for embrittling gases, maybe hydrogen or so. So it's partially taken with both metal and non-metal. So the weight comes down drastically, around 25 to 45%, but the cost again increases like anything. And the last is type 4, what we call is Gen 4. It is purely non-metal. So there is no metal involved in type 4 cylinder. Why we should go for a cylinder which is purely having only non-metal parts? We'll see that in the forthcoming slides. But for hydrogen, generally all the cylinders are type 4. So the slides which you saw in the previous slide, the images what you saw here are all type 4 cylinders, purely non-metal, wherein it's fully carbon fiber composite. So of course, type 4 has less weight, only around 30% is the weight, and but the cost is heavy, cost is very high. That is the trade-off which we need to do. But considering safety as one of the primary goal, ideally people go for either type 3 or type 4 cylinders. Yeah. So why I told you that we should go for non-metal. Why we should not go for non-metal? See, if you see here in the periodic table, hydrogen is the first element, which is lightest element, means the weight is very less as compared to other elements, and it's the smallest. So what happens is, let's say we have steel, that is iron and carbon. So if you see, the volleyballs are like iron part, and the hydrogen is like a golf ball. So generally hydrogen can go inside the steel structure and sit at the stress concentration area. So what happens is, when hydrogen diffuse into metal, they can weaken the structure of the metal. Weaken means they make it more brittle. So where it sits is really important. It sits, the hydrogen atom sits, maybe dislocation. So in dislocation, grain boundary and voids. And what happens is, when there is a hydrogen sitting inside the metal, it could be newly formed product, or it could be a 2-year or 3-year-old product. Whenever there is a stress concentration or any change in the external surface condition, the metal will crack from that point, and there will be a sudden collapse, and that collapse is generally due to hydrogen. Then it is called hydrogen embrittlement. So hydrogen embrittlement is a brittle fracture. It can happen at any point of time. If it happens, there will be a sudden blast. So metals are prone to hydrogen embrittlement. So ideally we avoid metals. Else we need to have a special kind of materials which are not susceptible to hydrogen embrittlement, which are of course very costly, and there are a few companies who have just started working on it, and we can see that in the news as well. So this is the primary reason why we should go for non-metallic cylinders when we are storing hydrogen. Takes time to change the slide. Yeah. So the effect of hydrogen on metals, it degrades, and the tensile strength need not be changed. The tensile strength of the material will be same, but what will change is the ductility, the fracture toughness, or the fatigue properties. So because there is a constant filling and refueling, emptying the gas and again refueling at that much high pressure, then the ductility, fatigue, and fracture properties will change because of the effect of hydrogen. And if there are any welding happening, welding will have a heat affected zone. So if two metals are bonded, then that heat affected zone is more prone to hydrogen embrittlement. So ideally we should not have any welding. If there is a welding, we need to really check the welding thoroughly. Aluminium, earlier people were using aluminium also, But there were incidents mainly in the scuba gears where they had an aluminum cylinder, and then people even started discontinuing the aluminum alloy as well. So now we will go. We have understood why what is the effect of hydrogen on metals. What are the type of storage solution? Now we will go a little bit deep dive into the storage system. So the hydrogen storage system means it comprises all the high pressure system in the vehicle. And what is the function of the hydrogen storage system? To receive the hydrogen from the fueling station. So it could be hydrogen or HCNG. So basically to receive the gas from the fueling station during the fueling, to contain it and release it as per the need, whether to fuel cell or H2Is. So presently, the most common method to store and deliver is through compressed gas. So that is the very well established methodology. But many of you may be aware, hydrogen has a very good energy density as compared to CNG or as compared to gasoline. But the volumetric energy density is poor. That's why we need to store in a very high pressure. Like as we saw, 690 bar in Toyota is the 700 bar is the Toyota pressure rating of the that cylinders. Then only we can compensate that volumetric energy density. If we don't want to store in a very highly compressed gas form, then what we have the option is liquid hydrogen. So storing it as a cryogenic condition. So that will compensate this problem. So the next one option is, of course, storing in a liquid form. But the challenge is storing in that negative temperature for a vehicle becomes a challenge. So there is some middle portion as well. Either it can be gas or liquid or in a cryo compressed hydrogen. So basically reducing the temperature of the gas and then loading it. So this is a kind of a hybrid in between liquid and the compressed gas. So if you see the cylinder, the diagram over here, generally we have three important elements: the shut-off valve, the check valve, and a thermal pressure relief device. So we will understand these what is the function of these equipments as well. So this is a high level schematic of the hydrogen storage system. As you can see, A is the hydrogen fueling, so fueling receptacle. Through check valve, we get the gases. In the B, that is hydrogen storage. Hydrogen is stored in very high pressure, so there is a regulator while delivering the hydrogen, that is number C. And then from C, it goes to D, that it could be in this case fuel cell system. So we have cathode, anode, and so on. Air gives the oxygen, and then of course the electric propulsion. So we have power management, batteries, capacitors, and motors, and so on. So this is a typical schematic of a hydrogen powered vehicles. And you see if you see in the vehicle, let's say in the car, you can see that generally hydrogen is stored at the front, at the back, and in the front you have all the driver, motor controller, radiator, power management, and so on. Fuel cell is at the under body, and there is again the braking system and fueling receptacle is there in the back. So this is for the car, and the temperature of the hydrogen in the different components of the vehicle, if you see. So you can see both location A and location B in the table. So location A is inside the engine compartment in an H2Is, and location B is elsewhere in the beyond engine. So you can see that the temperature exposure on the engine is -40 to 120 degrees Celsius, both in cold or moderate conditions. And similarly, outside the engine, the temperature will be around -40 to 85. So earlier, the engine did not experience negative temperature, but with this kind of new systems, the engine is going to experience negative temperature as well. So this you have to keep in mind while dealing with gases. And if you see a typical hydrogen fueling station, how it looks like. So there is a hydrogen, it's a dispenser, there are some temperature measurement happening, pressure measurement happening at the fueling station, a meter, a fuel line, a hose. So of course there is a dedicated nozzle for and communication protocol, and then we have a vehicle fueling receptacle which will take the gases, and this will have compressed hydrogen storage and TPRD, that is thermally activated pressure relief devices. And in on vehicle also we will have temperature and pressure sensor on the CHSS, that is compressed hydrogen storage system. So this is how a typical fueling station will look like. So we saw for the car. When it comes for a commercial vehicle, where we can see that hydrogen will play a very bigger role as compared to car, we have big space. So we can load a lot of cylinders on a commercial vehicle. So here you can, I could not understand location on board. So on board location means vehicle, the location on the vehicle. On the board means it is on the vehicle. So what you can see from the earlier slide is, this is the two orange, that is the cylinders fitted inside the car. And the next slide is, these are the cylinders, what you can see are fitted on the bus. That is on the top. Hydrogen cylinders are fitted. So it may vary from one OEM to OEM, but it's a typical understanding how the hydrogen tanks are fitted and how the hydrogen line goes on, and where is the fuel cell, what is the kind of hydrogen high voltage lines, and those is given in this typical image. And as compared to the truck, the storage is given here. And also you have seen in the image in my last slides, the actual image of hydrogen storage. So these are the typical location where hydrogen tanks are placed in a commercial vehicle. I hope I have answered your query to the student who asked about the location on board. So this is how the introduction part is. So now you know what is how hydrogens are stored, what are the types of cylinders, type 1, type 2, type 3, type 4, why we should go for non-metal, what is the danger of hydrogen, where it is located, and so on. Now it's more of a theoretical slides, but I want you all to at least go through these definitions, because these are important keywords while working in a compressed gas system, HCNG or hydrogen system. So the first one is, of course, hydrogen concentration. So that is percentage of the hydrogen molecules within the mixture of hydrogen and air. So it could be hydrogen and CNG. So what is the hydrogen concentration? So in our case in hBAJA, it is around 18% is the hydrogen concentration. And when we call what is hydrogen fueled vehicle, it is any motor vehicle that uses hydrogen as a fuel to propel it, which could be either including fuel cell or in engine. So as per this standard, they are categorized as hydrogen fueled vehicle. Then is the maximum fueling pressure. So while filling the hydrogen tank, we have to give in a pressure which is little bit higher than the actual hydrogen cylinder pressure. So generally it is 25%. So if the working pressure is, let's say, 100 bar, then while filling the hydrogen or the compressed gas inside the tank, the high fueling pressure will be 125 bar, that is 125%. So that is called the fueling pressure, maximum fuel. Then only gas will go inside the tank. And then comes the nominal working pressure. So what is the pressure with which the gas will be stored in the tank? At 15 degrees Celsius. So at 15 degrees Celsius, we measure the pressure, and that is called the working pressure of that particular hydrogen storage. Well, there is something called allowable working pressures, means how much maximum we can allow under normal operating condition. That is called maximum allowable working pressure. But generally, we restrict ourselves to nominal working pressure only. Then comes the pressure relief device. It is a device activated under particular condition to release the hydrogen from the system. and so that there is no catastrophic failure of the entire system. So that is called pressure relief device. If it is thermally activated, then it becomes a TPRD, that is thermal pressure relief device. SOC is a very common word used in electric mobility, state of charge, but here also there is a separate definition for hydrogen. So what does SOC mean? It means the density ratio of hydrogen in a compressed hydrogen storage system in the actual condition, that is the pressure and temperature, as compared to the nominal working pressure, that is at 15 degrees Celsius. So generally the temperature is 25 or 28 while running the vehicle. So in that, what is the density as compared to the density of the tank at 15 degrees Celsius? That percentage is called state of charge for a hydrogen based powertrain. Of course, you all know hydrogen sensor. We should have a hydrogen sensor which can detect hydrogen in air. I told you it is just not the tank, but it is also the fuel lines, fittings, and so on. So the fuel lines, fittings are also categorized into different classes. So this is class 0, class 1, and class 2. So class 0 has a fittings at a pressure greater than 3 MPa. So though we store it, let's say 70 MPa or so in the hydrogen tank, while giving the pressure at a fuel cell or at an engine, it is not that much. It is written somewhere in the slides. I will share, we will discuss at that point. So while delivering the hydrogen from the tank to the fuel cell or engine, these fuel lines or fittings are categorized into different classes. So if it is greater than 3 megapascal pressure, then it is called class 0 component. If it is less than 0.45 to 3, then it is class 1 component. And then if it is less than 0.45 megapascal pressure is only delivered to the engine or the fuel cell, then it is class 2 component. So generally, while working on the different components, you should know what class of components you are buying and what does it mean actually. Well, I told you there is wrapping happening, carbon fiber composite wrapping. So we can either say fully wrap, means it is wrapped around it fully in the all the two domes as well as the center portion of the cylinder. Then it is called fully wrapped cylinder. If it is only at the center portion only, that is the circumferential pattern only, then it is called hoop wrap only. So there is no, it is not wrapped under domes. So that is generally maybe for the type 3 or so. So that is called hoop wrap. Newton meter cube, it is the volume of dry gas that occupies 1 meter cube of volume at particular temperature. Service life, what is the life of the storage system? Generally, it is 15 years, but it has a limited life beyond which it cannot be used. So any cylinder which you are buying or which you will be using has to have its manufacturing date and service life. We already discussed container. What is a container? It basically contains the compressed gaseous hydrogen, and the assembly is interconnecting fuel lines, the shell, the frame, etc. If added, it becomes a container assembly. And duty cycle means one startup and shutdown of the entire hydrogen conversion system. And filling cycle, as I told you, it is 25% of the working pressure need to be used, and that is called a filling cycle. Pressure regulator is a device which controls the delivery pressure of this fuel to particular conversion system, maybe fuel cell or engine. So we will have pressure regulators. There are multiple stages of pressure regulation. So because we have 700 bar or storage or 350 bar or 200 bar in hBAJA, I believe it may be somewhere around 200 250 bar. So from 200 to 250 we need to regulate the pressure. So there are multiple first pressure regulator or second pressure regulator depending on the end application. Non-written valve, which is used for filling, so the hydrogen or the gas flows in only one direction. You all know what does pressure mean or what does the fitting mean. Fittings could be flexible. There could be flexible fuel line or it could be rigid. There is also a heat exchanger for heating the hydrogen. When it is used for a liquid hydrogen kind of system, generally a heat exchanger is used to deliver the fuel to H2Is or so. There is a hydrogen filter to remove the oil, water or dirt if it is present in the entire system. There are multiple automatic valves, non-return valves, which operates based on certain limit set by the manufacturer. We spoke about pressure relief device. It could be either one-time use or maybe multiple use, depends. So pressure relief device is a non-reclosing device, and pressure relief valve is a reclosing pressure activated device, which is generally at particular pressure it releases the fluid from the hydrogen system without damaging the tank. A receptacle is a definition to receive the hydrogen from the station. Boil-off management system. This is a very important keyword. When we are using hydrogen in a liquid form, boil-off management system plays an important role in order to compensate the pressure being generated inside the liquid tank and releasing those pressure so to prevent the damage to the liquid hydrogen tank. So that is called boil-off management system. So a typical compressed hydrogen storage system, it contains, of course, the compressed hydrogen gas, and the hydrogen storage system need to be physically constrained through the outer protection device of the container. So we spoke about the energy density, and also the volumetric energy density. So in order to compensate the volumetric energy density, we are using compressed hydrogen storage containers at very high pressure. So in India, we use 35 megapascal. That is the norm in India. So whatever the earlier prototypes have been made are made for 350 bar or 35 megapascal. And the Toyota Mirai, which has a global benchmark, Mr. Nitin Gadkari uses the same in the parliament. For those tanks, the rating is 70 MPa, that is around 700 bar. So the fueling pressure is 25% beyond the 35 and 70. That comes to somewhere around 43 megapascal and 87 megapascal is the fueling pressure. So during the normal fast fill, we need to add that 25% and also maintain the temperature. And the temperature for a nominal working pressure need to be checked at 15 degrees Celsius. So different pressure are possible in the future as commercialization proceeds, because if we store more hydrogen, we get more range or more mileage, but then the tank also need to have that kind of rating. So the pressures, it could be 70 MPa or it could be 50 MPa, depends on application to application and the entire range calculations. So basically, when we go for a higher pressure, they are currently constructed from composite materials only to meet the safety challenges. So the most high pressure hydrogen storage containers which are used has in either in fuel cell or ice has two layers. So the inner layer is the plastic layer which prevents the hydrogen from leaking or permeation. It should not happen. So there is a thermoplastic polymer, and that is the first layer, and the outer layer is the structural layer, which is the carbon fiber composite wound on top of the plastic liner. So there are only two layers of construction when we talk about type 4 cylinders or type 3 cylinders. So we cannot store the entire hydrogen in only one cylinder. So it could be a single chamber or multiple cylinders connected permanently, and the disassembly should not happen. That is, it should be permanently fixed. That is the idea. So it will have multiple, a container may have attachment that are non-pressure bearing parts, which can add more protection to the container. So there will be a check valve. So during fueling, hydrogen enters through a check valve, and the check valve prevents the backflow of hydrogen into the fueling line again. And there is also a shut-off valve we saw in the schematic. So there will be a shut-off valve. So when the vehicle is operating or if any fault is detected, then an isolation need to be done between the hydrogen storage and the actual system. So a shut-off valve isolates that, and that is the actual work of the shut-off valve. And if there is any fire happening, then there will be a thermal pressure relief device. So a fire will increase the temperature. When there is a detection of high temperature happening near the storage system, this TPRD will take control and start releasing the gas out. So it plays a very important role for venting the entire content. And it will not then again do the repressurization, is generally not possible. So even during the 26/11 attacks in Mumbai, there were multiple CNG buses, but there was no failure of CNG cylinders happened. So the entire valves, the fittings are designed in such a way that there is no burst of CNG cylinders. So till now we spoke about more on the gas part, and coming a little bit on the liquid part also. Though it is a little challenging, still I just want to give you a flavor of liquid hydrogen storage system. So we spoke to overcome the volumetric energy density disadvantage. People go with liquid hydrogen storage system at cryogenic temperature, so around minus 250 degrees Celsius or so. So we all know we use Milton water bottle to keep the water hot or cold. The construction is typically of that sort of only. So in order to maintain the hydrogen in the liquid state, the container needs to be well insulated. So then there is a vacuum jacket that surrounds the container. But there will be some long parking time. There will be some heat transfer will happen. If there is any heat transfer, then there will be a pressure rise within the container. So I told you about boil-off management system. So it detects the heat leakage, and if there is any pressure rise, then this boil-off management system kicks in and releases that. And this released hydrogen can be consumed in some downstream system. Maybe the fuel cell or the engine can use the hydrogen as well. So discharges from the vehicle due to overpressure should be addressed, as how much leak should be allowed as part of this kind of discharge. So you can see here, this is a vacuum jacket and then hydrogen storage container. So this is the kind of Milton bottle construction, and of course there are multiple pressure relief devices, boil off system, and then fuel receptacle shut off devices, shut off valves, and then going to either fuel cell or engine. So when we talk about tanks and also liquid hydrogen, there is something called thermal autonomy test. So whatever test or whatever definition I am sharing, are all part of some regulatory standards. So there are 11119 and so on, 12619, which you can refer for in detail description. So thermal autonomy test is really important. So I will just read through. So the inner tank shall be at the same temperature as the temperature of the liquid hydrogen. During the previous 24 hours, the fuel tanks has to be at least half of the entire inner tank. And then we need to put some fire onto it. So we put a fire. The fuel tank shall be filled with liquid hydrogen, and it has to be measured within the 10% maximum allowed quantity. And the fire, the length and width of the fire shall exceed the dimension of the fuel tank by at least 0.1 meter. So fire will be engulfing the liquid hydrogen tank, and the fire temperature should be almost 590 degrees Celsius. I think there was some question, but it got skipped. Maybe we can discuss it during the Q&A also. So 590 degrees Celsius is the kind of a temperature at which the entire storage system is tested. And we have to see the pressure of the tank from 0 to 0.01 until the boiling point. And the thermocouple should mention 590 degrees Celsius. And we should know when the pressure relief valve opens. So basically the acceptance criteria is the thermal autonomy should not, which is the lapse of the time, shall not be less than 5 meters. So if there is a fire, the time given is 5 minutes for thermal autonomy. This entire system should hold for at least 5 minutes, so that there is a proper egress and everything is safe before any pressure relief happening and so on. So this is called thermal autonomy test, which needs to be done for liquid hydrogen, especially. So we spoke about hydrogen fuel delivery system. A delivery system will have flow control valve, pressure regulator, filters, piping, and heat exchanger. And the liquid hydrogen system, both liquid or it could be gaseous hydrogen system, will go to the internal combustion engine or fuel cell. Similarly, in vehicles with thermal conditioning is required. As I told you, hydrogen gas is also in a very low temperature, that is 15 degrees Celsius, or if it is a liquid hydrogen, it is still furthermore. So some thermal conditioning may be required in order to reach to, before reaching to engine or so. The fuel delivery system shall reduce the pressure also. So multiple level of pressure reduction need to happen before going to the engine. So as I told you, the hydrogen storage is around 70 MPa. But when going to the fuel cell, the pressure needs to be reduced from 70 to 1 MPa or even 35 to 1 MPa. So the fuel cell at the inlet, the fuel cell only requires 1 MPa pressure of hydrogen. If it is an engine, then it may require around 1.5 MPa of pressure at the engine side. It may change from OEM to OEM, but you get the idea how much pressure regulation need to happen. So the overpressure protection need to be ensured if there is any hydrogen gas supply during the downstream system or so on. So this is more of a theory what we saw. Now the test, what kind of test generally is done for any hydrogen storage system or any compressed gas storage system. So generally the test is divided into three major areas. One is baseline. So let's say if you get a cylinder, what is the baseline? Basic testing. So that is called baseline metrics. Then we go for performance testing, and then we go for fire testing. So baseline is like, proof burst test. So the pressure is increased to a level where there is a burst of cylinder happening, and we understand what is the burst pressure. So once we know the burst pressure, we can design the entire system according to that burst pressure. So that is one of the important tests. And then of course there can be also pressure cycling at particular pressure, maybe test pressure or working pressure. And as I told you, the life of the tank is around 15 years. When we say 15 years, it corresponds to somewhere around 11,000 cycles of charging the gas and discharging the gas. So much of cycling for if it happens, let's say 11,000 cycles without leakage, then it is rated for 15 years or so. And we can also do till 22,000 cycles and see that there is no rupture happening. So this is called a baseline testing. And then there are standards, AIS standards, IS standards, which talks about different performance durability. So you can see here, there is a proof pressure. So x-axis, y-axis is pressure and x-axis is time for both the graph. So in the first graph, it is hydraulic. In the second graph, it is pneumatic. In the first graph, it is more of a lab. Here, it could be more of an on-road performance. So you can see proof pressure going up to 150% of working pressure. Then you need to do drop testing. Let's say at around 1.8 meter height, we do drop testing. And then we do damage, chemical damage. So we put some acid or base solution and damage the cylinder surface, and then again do for, at 125% of working pressure, do 60% of the cycle. So 60% of 11,000 cycles is somewhere around 6,500 cycles. So doing around 6,500 cycles at a temperature of 5 to 35 degrees Celsius, and then going to 150, and then holding it for 1000 hours at 85 degrees Celsius for 125% of the working pressure, and then remaining 20% cycle at -40, and the rest 20% at +85. So different temperature, different pressure, we need to do the entire testing of the cylinder, and last is burst, break that cylinder. So this corresponds to the performance testing of the storage system. Similarly, for onboard also, they have given different types of cycling which we may like to follow. And the last is of course fire testing. We saw the 590 degrees Celsius or so. So typical image of cylinder testing and thermal imagery of those. So and we have to understand how it looks like you are sharing videos. Do you want to include? No, there is no audio here. It is just the image. And of course, there are multiple tests. There are so many tests are given. I will just review a few of the tests, and I will also show some of the case study. And if required, we can discuss some tests in detail. So these are some of the important tests from the metal point of view, from the materials point of view. So one is oxygen aging. So all non-metallic parts that has a sealing should not crack or should not deteriorate after oxygen aging. So oxygen aging means around 96 hours of exposure to oxygen at a 70 degrees Celsius temperature at some pressure, like around 20 bar pressure. So we have to expose the metals for that particular condition and then see if there is any crack happening or any deterioration happening on the fuel lines or seals, which is used for this kind of high pressure hydrogen storage system. So these things may not be of direct useful to you in hBAJA, but while going for any placements or talking to industrialists, you need to know this test. So one is oxygen aging, and then the second is ozone aging. So ozone is O3. So during ozone aging also there should not be any crack or any deterioration happening. And there is some ISO standard which need to be followed. And the test piece has to be elongated by 20%, and then it has to be exposed for 40 degrees Celsius with an ozone concentration of 50 parts per 100 million for 120 hours. So this is the kind of specification given in the standard, and the material has to withstand and should not either crack or deteriorate through visual inspection. Then is non-metallic material immersion. So we have to prepare, measure and weigh a representative sample of the material which we are going to use in our hydrogen system. And then we have to, at particular pressure, not less than 100 kilopascal, for 70 hours, we have to immerse it. And then see if there is any swelling happening or any shrinkage happening. Then that has to be noted down for that particular gases. So there should not be any weight change also, not more than 10%. So this is called non-metallic material immersion test. Then of course, we also have to understand the exposure of hydrogen on the effect of material. So this is called pre-cooled hydrogen exposure test. So it so basically either liquid hydrogen or gaseous hydrogen, the hydrogen will be in a very cold state. So when the hydrogen flows through this receptacle to fill the tank, there are so many systems. So this needs to be tested at minus 40 degrees Celsius at a flow rate of 30 gram per second. And then it could be at 15 degrees Celsius, and there is some duration given 30 seconds. So basically it has to be repeated multiple times, and we have to see on multiple cycles. So basically understanding the effect of these fuels, lines, fittings because of the cold hydrogen gas flowing through that. So there are multiple standards to it. So I just showed you 4 tests. I will just run through multiple other tests, the only title to it. And there are so many standards as well. So automotive industry standard is one important standard framed by the technical secretariat of ARAI. And if you see, the nominal working pressure is measured at 15 degrees Celsius and the temperature is around minus 40 degrees Celsius. So till now, internal combustion engine has not experienced this kind of temperature. So this is really a new parameter added in engine research. Temperature, low temperature is a new parameter added in engine research. So when we add new parameter, what happens? So we all know Titanic, and many people may be aware why it failed. So Titanic failed because of 100% brittle fracture. So it broke in 2 parts. But if you see the actual condition, the temperature of the water was around negative 2 degrees Celsius, not that cold. It is not negative 40 or so. So the temperature of water was around negative 2. and it hit the iceberg, and the DBTT, the ductile to brittle transition temperature, the steel material which was used underwent from ductility to brittle not at -2 degrees Celsius. It happened at 40 and 70 degrees Celsius. So at a very hot environment also, if Titanic would have hit an iceberg, it would have failed. Not only the ductile brittle transition temperature, but also there was high level of manganese sulfide and oxide particles. So a basic Charpy V-notch test was not done, unfortunately, and that led to this collapse. So the ductile to brittle transition is something will play an important role in future engine research when hydrogen gas is being used. So here the ductile to brittle transition is a high energy plastic deformation from ductile to shattering, that is brittle. It is of course found mostly in BCC and also HCP structure. So what happens is when there is a fracture, 50% is brittle and 50% is ductile. If that is the kind of the fracture surface wherein 50% is brittle and 50% is ductile, then we call it ductile to brittle transition has happened. And it gets related with different aspects also, like the metallurgy aspect, like vibrations or grain size or dislocation density. So if there is a less vibration, the more brittle. High dislocation density, if the material is already damaged, then the brittleness will be more. Or the grain size, if it is small, then the brittle fracture may happen faster. So here you can see the S-type curve. So generally it starts from right, it is purely ductile, and there is a transition from ductile to there's a drop, and then it's a pure brittle fracture. But there is a simple test called Charpy V-notch test. If we do that, we will understand what type of fracture is happening. So you will be using a lot of materials in the HCNG system or in the future research. At that time, you have to understand that the effect of temperature need to be validated by doing this kind of simple test. And this image, you can see ductile, very ductile, it will be like pinpoint and then it will fail. Brittle is like glass shattering, which is given in the blue color. So this was one of the paper which we published when I was in the area, and we understood the effect of low temperature on different materials, basically forging material, which becomes the crankshaft in the engine or maybe the valves in the entire hydrogen fuel system. So there are 3 different materials were selected at high temperature, 35 to -30. The materials were prepared and tested for its impact strength. So I'm just giving you a case study of how you can also do this kind of study, and this machine is generally available in all the colleges. So you can see the S curve. We also found an S curve, and there was a ductile to brittle transition happening different temperature. And you can see that we used 3 material. So 40 CR4 was one of the best, and at 15 degrees Celsius we could see the transition happening for all the 3 materials. And this 15 degrees Celsius is also important when we talk about hydrogen storage, because working pressure is measured in 15 degrees Celsius. So 15 is really important number in hydrogen system, as well as in all the 3 materials. General material, you can see that brittle transition has happened at 15 degrees Celsius. And this too was not that good because of maybe sulfur content. So in the Titanic slide, I told you that there was manganese sulfide in it. So sulfur can become sulfide. That could be the reason because of non-performance of these 2 material as compared to this one 40 CR4, where the energy was high, let's say 68 as compared to 58 or 60 in the 42 CRMO4 or EN8 material. So this kind of simple study will give you a lot of understanding of the effect of temperature on the steel material or any other material as well, aluminum or magnesium. So the density of hydrogen changes. So this is a typical graph. You can see when the pressure from 1 MPa to 87.5 MPa and the temperature from -40 to 85, the density changes from 0.7 gram per liter to 53 gram per liter. So the density of hydrogen changes with respect to temperature and pressure, and this also you have to understand while calculating your range or so. So we spoke about hydrogen embrittlement. So it is just not in only pure hydrogen. So when we call it embrittling gases, means a gas. Sir, can you once repeat? Uh, I don't know which slide you want me to repeat. The previous one, the hydrogen density. Yeah, table. Yeah, okay, great. So you can see it is pressure MPa. Pressure is given in MPa and temperature in degree Celsius. So the temperature starts from -40 till +85, and the pressure is from 1 MPa till 87.5 MPa. So your hydrogen storage system or any compressed gas hydrogen storage system will have some pressure and will have some temperature. So the density is really important. So you have to know what is the density of the gas. So for hydrogen, the density varies from here, bottom left, you can see 0.7. That is at 85 degrees Celsius, 1 MPa bar, the density is only 0.7. But it increases exponentially to 53 grams per liter when the pressure is 87.5 degrees Celsius, 87.5 MPa, and the temperature is -40. So the density calculation can help you in converting to the range also, your vehicle range. I hope that is clear for the student. So we spoke about hydrogen embrittlement a lot. So these are a few important words you should know, technical words, while talking about hydrogen embrittlement. So what are the gases which can cause crack in the metal? So the gases which has hydrogen will be considered as an embrittling gas. So when we say embrittling gases, it means that it has the tendency to pass hydrogen atoms inside the metal and crack it. So in HCNG is also an embrittling gas. Pure hydrogen is of course a embrittling gas. So so these are called embrittling gases. Not only hydrogen, there may be any other thing also, but they are classified under embrittling gases. So what people do is there is something called two different tests which is predominant. One is disc test and the second one is fracture mechanics test. So basically there is a disc of metal, they cut it around 58 mm and then it is exposed to some pressure, and we have to understand when the metal disc ruptures, at what pressure. That is called hydrogen rupture pressure test. So when a hydrogen gas is used, that is called the hydrogen rupture pressure test, and we record the maximum pressure. When a helium is used, it is called helium rupture pressure test, and we have to record that maximum pressure as well in the disc test. So basically it is a disc and the pressure is given from one side, and we have a compensating pressure and understand the effect of pressure on the metal rupture. So then we can understand what is hydrogen embrittlement index. So hydrogen embrittlement index is the maximum pressure, maximum value of the ratio of PHE, that is helium rupture pressure test, divided by hydrogen rupture pressure test. So that gives the hydrogen embrittlement index for any particular metal. So when we talk hydrogen embrittlement, we can always refer to its hydrogen embrittlement index. And of course, it is just not the hydrogen, there is also environmental assisted cracking. So metal will undergo particular environment. It could be corrosive, non-corrosive, humidity, humid, less or more humid. So it could have some tensile stresses, residual stresses, or it may not have tensile stresses and it may have compressive stresses. So these are the environment which the tank could be exposed to, and that will also enhance the cracking, that is called environmental assisted cracking. So fracture mechanics test, wherein we create a notch, we have K1H and so on, and then we understand the effect of hydrogen atom on the fracture mechanics part. That is also called fracture mechanics test to check the embrittlement damage on the metal. I hope you are clear with the embrittlement, because hydrogen is something new, and whenever we talk about hydrogen, the first thing we speak is embrittlement. So when we speak hydrogen embrittlement, you may like to talk about hydrogen embrittlement index of particular metal. So that's it with respect to the content of the presentation. I have few of the slides which talks about different tests. I'm not going to talk in detail about each test because it will be more of a theory then, and it will be always already boring. Generally, the presentations, if it goes beyond 45 minutes, the listening capability goes down, and having so much of content, we were forced to do this lecture for more than 45 minutes. It's almost an hour and 5 minutes. So I will just run through the test, the name of the test. You can just hear it, and if someone is interested in the test, we can discuss it in detail during a Q&A, or you can of course Google it or connect with me later on to discuss more about that test and understanding those tests. So any compressed hydrogen storage system will need to be passing around 20 tests, 20. So once it passes 20 tests, then it can be given approval by the regulatory body. So first test is the liner material. So liner material is generally metal, that is aluminum liner, or it could be non-metal, thermoplastic, simple polymer. So the liner need to be tested for its strength, for its pressure capability, for its permeation, the gas permeation. So that comes under liner material test. Then is the resin shear test. So resin shear is basically there is a resin. So carbon fiber, when we are winding it, there is a resin added. Then only the resin can hold the fibers. So understanding the effect of resin, its strength on the carbon fiber need to be checked. That is called resin shear test. Then is the overwrap material test. So overwrap is basically the carbon fiber composite. So we have to understand the effect of carbon fiber composite strength on the cylinder. So it could be tested on a material level with resin and without resin. So that is called overwrap material test. Then comes the proof test. So we have test pressure, we have working pressure, we have burst pressure. So checking the cylinders for its different pressure capability, that is called proof test. And if there is any elastic expansion happening during these tests, so understanding that, so elastic expansion can be measured based on the volume of the gases inside it. So that is called hydraulic elastic expansion test. So these tests need not be done only with hydrogen. It can be also done with maybe hydraulics or pneumatics or even with normal air. Then cylinder burst test. Cylinder burst is like breaking the test, breaking the cylinder till its UTS. So that is called burst proof. So burst pressure, we have to understand the limit of the cylinder. So that is called cylinder burst test. Then we have ambient cycle test, that is at different temperature and humidity condition doing cycling, let's say 11,000 cycles or so. That is called ambient cycle test. Sometimes the cylinders are used in vacuum application, maybe in underwater vacuum application, and or maybe in aerospace, satellite based application. So when there is a vacuum being exposed to the storage system, we also do vacuum test. Then we have environment cycle. It could be corrosion environment like sodium chloride or calcium chloride kind of environment, and understanding the performance of the entire system. That is called environment cycle. Drop or impact test. It is basically dropping from certain height, maybe around 1.8 meter to my understanding. So at different angles. So and checking the rigidity of the tank. So then that is called drop test or impact test. And then we also have a high velocity impact. So basically high velocity impact is firing the bullet. So the cylinders are kept and the bullets are fired, and they check the penetration of the bullets on the tank, and whether the tanks are still in single one piece or it shatters or what. So that is called high velocity impact test. Stress rupture test, we already spoke about environmental assisted cracking, so it's something like that. Flaw test, so we create a particular flaw, we induce flaw, maybe horizontal flaw or a vertical flaw. We through a knife we cut the cylinder with particular depth, and then checking the cylinder for that with that flaw whether it will sustain or not. So that is called flaw test. Fire resistance, I already showed you some of the images. So at very high temperature, how the system performs. So the entire cylinder is engulfed in the fire and checked for its withstanding capability. That is called fire resistances. Permeability. So hydrogen, very light atom, it permeates and it leaks. So we have to understand the permeation effect on the cylinder. So that is called permeability test. Torque. So the cylinder is fitted with some walls and the walls are fitted with some torque. So we have to understand the effect of particular torque on the metal boss attached in the cylinder. That is called torque test. Then we have salt water test, leak test. So basically, if there's any leakage happening on the cylinder, post different testing. Pneumatic cycling, we can do pneumatic cycling test. Liner burst. So not the carbon fiber, just the liner. If we check it till burst pressure, that is called liner burst test. There is also something called glass transition temperature, where the polymer becomes soft or ductile and loses its hardening capability. That is called glass transition temperature. So understanding the glass transition temperature will help us while exposing to high temperature. So with this, I conclude my presentation. So these are the different tests available, which we can discuss in detail when there is a the need. So now I'm open for any questions. I think I'm almost on time, and
Yes, sir. Sir, thank you so much for the insights, and we are really obliged to have you with us today. So, with your permission, may I start the Q&A session?
yeah, yes.
Okay, so the first question that came to us was, what factors should be considered while choosing onboard location of H2 cylinders?
That's what the presentation is all about, right? Means now there are so many parameters. You one thing, if you want to answer in one line, then hydrogen embrittlement is something really dangerous. That parameter need to be seen while selecting any component.
Okay, so second was how to do leakage testing of H2 storage system without using CNG or HCNG.
How to do leakage testing?
Yes, sir. How to do leakage testing of H2 storage system without using CNG or HCNG.
So leakage you can even do use soap oil, maybe bubbles or something. Means if there is a leakage, you can easily find out. If there is a leakage of hydrogen gas, I don't know. You need not go till that, but the cylinder need to be in tight to ensure that there is no leakage. And for that you can use any standard fluids.
Okay, so moving on to next question was, while calculating hydrogen concentration, we should consider the hydrogen present in methane or not.
I'm not sure methane how it comes, but I understand for hBAJA it will be 18% with CNG. So I think your hydrogen concentration will be somewhere around 18% mixed with CNG.
Okay, next question is, could you provide us some guidelines about type 3 or type 4 cylinder handling, including what to do and what to avoid?
Of course, you have to handle it carefully. Type 3 or type 4, it is lightweight. So you have to use proper valves and fittings so that the maximum value is derived out of the type 3 or type 4 cylinders. And what you should not do is you should not maybe do any mechanical damage or so, because we need to at least sustain till this entire competition. So please make sure that the fittings of the cylinder on your vehicle is all degrees of freedoms are constrained. So there is no any loose ends, and the opening of the cylinder is not exposed to dirts or gravel, so that it is nicely protected, so that during off-roading condition, the cylinders are not damaged. So basically, as a student, you can focus on fitting the cylinder and avoiding the damage from external condition. That should be your goal.
Okay, sir. So that was it for our Q&A session. So thank you, sir, for that comprehensive and enlightening session on both of your topics. And understanding these critical specifications is surely essential as we advance towards a future powered by a cleaner energy solution. So thank you so much, sir, for being with us on board today. Thank you.
Thank you. Thank you, everyone.
Moving on towards our session 2, it's for vehicle overall packaging and system integration. So for this session, I'm inviting Mr. Piyush Balia from Atul Auto. He's a senior manager at Atul Auto Limited, overseeing R&D, vehicle integration, and program management since 2007. With prior experience at General Motors from 2003 to 2007, he brings extensive expertise in automotive development. Mr. Bhalia brings his extensive expertise in vehicle design and integration, ensuring that all components work harmoniously in natural gas powered vehicles. So let's welcome him on board to the stage.
So, thank you, Nani, and good morning, all of you. Since last 1 year, we as a Atul Auto Limited participating in this hBAJA event. So, thanks to all hBAJA team, Dr. Hora sir, who introduced the Atul Auto in this event, and myself, Piyush Bhalia, as explained by Nani, coordinating from my organization with hBAJA committee. So not wasting the much time, and last session was a very important and knowledge gain lecture for the upcoming technology in automobile industries. So it was a fantastic learning so many new things. Okay, so now my session is about the vehicle integration. So let me share my presentation. Is my slide is visible?
Yes, sir.
Yeah. Okay. So yeah. Now last 1.5 days we have a session about various system, engine, regulation, CNG kits, all those things. So now the session is like two vehicle performance. How this system should be integrated as a whole and how it will perform with the proper safety and regulations. Okay, so there is a basic systems mentioned in this slide, which together give a performance of the vehicle. Okay, so there a exhaust system, power source we call as a engine, a suspension system, transmission, engine cooling system, air intake system, fuel supply system, and electrical. The engine system, Dr. Kalim yesterday already explained to all the team members about power source and exhaust system and engine. So we today will cover exhaust system, air intake system, cooling system, fuel system, and electrical system. Most probably last year we have supplied this system to this event. Okay, so we'll see how system will be integrated on the chassis frame along with the power source. So let's go one by one. So these are the system list, and also a few general tools and fasteners you should have during the event and integration of the your vehicle. So here first we'll discuss about engine mounting concept. Yeah. So engine mounting means we have to place the engine on the chassis frame. Okay. after connection with the chassis should have minimum vibration and hesitation. So further reduce the vibration and sound level, we have to use AVM anti-vibration mounting pads and all kind of thing to absorb the vibration after installation on the chassis. So which kind of vibration pad available with us or we are using in our three-wheeler? Okay, so we'll go with the presentation of AVM which we have supplied. Okay. So this is a two types of AVM mounting we are using vehicle. So similar kind of mounting arrangement you can select and package to engine with the chassis frame. So this is a first one is a AVM. It's a rubber bonded sheet metal parts. So it will absorb and connected between chassis and engine. So this is the engine tray and this is the engine which you will must probably procure from Greece. So this will be connected with this frame and this frame will be connected with this AVM and AVM will be connected with the chassis frame. So this is a one kind of arrangement in which you can use the this type of AVM for the vehicle packaging. So these are the fastener details and there is a 2-point mounting system for the engine. This is a chassis frame which you probably make a roll cage. This is another type of mounting arrangement. So we have two kind of arrangement. So first one is last time whoever participated in hBAJA event, they have packaged the vehicle with the first kind of arrangement. This is another type of mounting arrangement having a 3-point mounting. This is for the integrated engine with gearbox. So in your case, there is a separate gearbox with belt drive. So first one is the more suitable for your vehicle packaging. So these are the parts how exploded view. This is a rubber AVM anti-vibration mounting pad integrated with this bush and packaged with this frame. So this is another kind of mounting arrangement for that engine mounting on the chassis. So this is the actual parts photographs with the proper name. This is again detailed front and rear mounting points. The front side there is a 2 mounting point, rear side is a 1 mounting point. So this is a balance to maintain the CG. So if you can have a CG points of the engine, you packaged very well on the chassis frame. So this is all about the engine. Now we'll go for the air intake system. So there is a main part of intake hose, rubber tube, bellow, and OMS2 bellow. Okay. So these are the packaging system for 400cc CNG engine which we are going to use for hBAJA event. So these are the parts. This is a air filter. This is the air filter system. This is the intake hose from filter to carburetor. In PWM valve, there is a idle air control circuit. So when engine is running in idle condition, this PWM valve operate for the idle RPM to provide the air supply from filter to manifold. This is a oil mist separator tube. So whenever engine running, there must be a blow by gases. So it will go to the top of the engine and going to the oil mist separator unit, and the oil will again inside to the chamber and gases will go into the intake system. So this is a closed circuit for the blow by gases. This is a mandatory for the BS6 regulation. Then we'll go for the exhaust system. So exhaust system most probably supplied from the Greece. There is a two main part of the exhaust system which we are going to use for the two parameters. One is the reduce the noise, and second one is the filter the gas according to emission norms. So their first part is connected with this cylinder head is a exhaust tube. Inside there is a catcon. So there is a catcon element with the different kind of material loading. So it will filter and process the gas and reduce the less pollution to the environment. So here we will see what kind of catcon, or we have to use only just exhaust tube without any catcon. Okay, last year we were used without catcon, and this year Dr. Vora says he will go green event will use catcon also. The student can optimize the performance and measure the exhaust gas emission level. Second part is connected with this exhaust tube is a muffler. This is specially used for the sound reduction, and different path of gases flow inside the muffler and finally exposed to the environment. So this supply also we are getting from the greaves. Okay. So we'll decide later on once the HCNG engine tested by grease, we'll see if there any changes required or not, because there is a mist and water content will be there in the HCNG engine. So after testing, we'll know what will be the changes required in the exhaust system. This is a cross-sectional construction view of the muffler and exhaust tube. So there is sheet metal outer body, then foil and fiberglass reinforcement used for the damping the sound, and then porosity with the tube. So it will release the gas one part to another path and reduce the pressure and sound. So this is the overall concept of the muffler. So these are the fastener we need to use for the exhaust system. So this is for information. All student will get this presentation, so you come to know which parts name and size and all those kind of information available with this presentation. Here we have mentioned the entire exhaust system assembly and the sequence. How you should tighten the exhaust system on the engine and chassis frame. So there is a sequence A, B, C, D, E is to provide a sequence to accommodate stress-free assembly. There is a slot and hole provision on the different kind of mounting arrangement. So if you tighten first, there is a hole, and if you tighten that location initially and then you go to the slot, then it will be okay to accommodate variation of different kind of parts. So that's why they have provided slots. See, here is a slots. So first we have to tighten fixed mounting. Say for example, here is a nut welded with the flange. So we start from here A, then B location, then C location, then D, and finally E. So these are the sequence for the tightening process of the exhaust system with the matting parts. Now we'll go for the engine cooling system. So there is a many kind of parts involved in this cooling system. Okay. Say for example, T-joint, fuel pipe, clamp, filling hose, rubber tubes, radiator and fan assembly, coolant recovery tank, and remote filler neck assembly, and rubber tube. So this is the overall layout for the concept. If you can see, this is a radiator. This is a sheet metal frame holding the radiator, and this blue one is a fan and shroud cover. So it will be integrated with this sheet metal frame. These are the hoses, and this is a recovery tank or reservoir tank. You can say this is a filler assembly, and this is a return line and bleeding hose. Package the material of hoses, most probably use EPDM braided type. Braided type means there is a rubber compound along with the wire strand or thread strand. So it will give additional strength to the rubber compound molding. So we can call EPDM braided hose. Minimum wall thickness should be 5 mm required for this application, and the rubber compound should withstand -40 to 125 Celsius of the temperature, and it should withstand minimum 1.4 bar of pressure. So these are the overall general specification to use rubber hose on this engine. There might be a different kind of specification for different kind of engine. So we are talking about our this 400cc CNG engine which we are going to use for hBAJA. This is a radiator specification which we are going to use for this application. Airflow rate for the fan is the 3.2 to 3.5 meter per second. Water flow 22 liter per minute. We'll use the ethylene glycolose based coolant with the DI water. So it's a mixing of the water and ethylene glycol. We use generally 50, 60, 40 or 50, 50% of the both material. So heat dissipation of this radiator system is 6,500 kilocalorie per hour. So this is the capacity of the cooling system. Water holding capacity for entire system is 1 liter and dry weight is around 3.8 kg. So now we are going to air bleeding process from the cooling system. So this is the most important process after the packaging of cooling system and engine. Okay, once you package these components with the matting, this process must need to be do carefully because there is a air trap in the inside the cooling system. Cooling system may not be work, engine get overheated and it's get failed. Okay, there must be a piston seizure and head failure, cylinder head gasket leakage. So all these kind of problems can occur if we'll not do air bleeding properly from the cooling system. So here we have mentioned step by step entire cooling system air bleeding process. So you can see the step one is location of the air bleeding screw and a radiator pressure cap. So this is a air bleeding screw. From there we have to escape all the air from the entire cooling system. This is the pressurized reservoir cap or filling cap. There is a two type of function. One is to fill the coolant in the system. Second one is the pressure release cap. So there must be if certain pressure occurs in the system, this cap will go away from the system. So it will save the engine life. So there must be a pressure mention on the cap. So we have to use specified pressure relief cap. Steps 2, do not remove the indicator pressure cap when engine is hot. So in this condition, be careful during the engine system. If engine system is hot, you should not open this cap until the cool down till the ambient temperature. So be careful during the system integration. So third step is how to open the cap. So you slightly press the cap first and then rotate either side or other side. So open and close. So there is a spring and a pressure relief valve inside the cap. Step 4, remove the pressure cap and fill the premix coolant, that is a ethylene glycol plus water 50-50%. Then start the engine and you have to open air bleeding screw from the engine which is located near the tappet cap. So once you open the screw and the engine is running in that condition, the entire coolant system will flow in the all passages through the water pump. There is a water pump on the engine, so coolant will flow in entire system and it will escape the air slowly from this screw. So once all air went out from the system, and we can see the coolant is coming from the screw, and we can have to tight the screw. So once air bubbles stop and only coolant flow is visible, tighten the screw with hand. Okay. So then finally tighten air bleeding screw with the suitable spanner. Secure the radiator pressure cap. Turn off the engine. So this is the radiator function, how to air escape from the cooling system. And there is a thermostat valve in the system. Radiator cooling system is not just for the cooling of the engine. Here the main whole purpose of the cooling system is optimize the engine performance. Optimize here I am saying to that is when engine is cool, okay, there is a must be say for example 15-degree temperature of ambient. In that case, the entire coolant will not flow through the system. There is a thermostat valve in between radiator and engine. So once engine gets certain temperature of the cylinder head and block, then only this thermostat valve will open and start the flow for the cooling of the cylinder head and engine system. So thermostat begins to open at 72 degrees Celsius of the temperature and completely opening at 80 degree of coolant temperature. Okay, and temperature sensor send a signal to the ECU which controls the operation of the fan. When once the temperature reach up to the specification, there is a ECU control send the signal to the fan. So fan will start through the signal and reducing the temperature of the cooling system. So fan will turn on at 84 degrees Celsius and turn off at 78 degree of Celsius coolant temperature. So these all our specification is now as per the current engine specification which we are running for the CNG. So again, maybe it will get changed if required after the calibration of HCNG at the grease end. So maybe final version we'll see after the calibration of done engine with HCNG at grease cotton limited. So here is a few notes. Always mix water and glycol 60-40. Ensure proper air bleeding of the cooling system. Check for any leakage. Once bleeding process is completed, there should not be any leakage required. If there is a leakage, then system will not flow the cooling to the engine. Again, air trap will be there if leakage is there at any joints. Coolant level should be maintained regularly in recovery tank. Ensure air cooling system hoses are away from the engine heat or sharp edges. So when you package this system, you must have to note that okay, hoses are away from the hot part and moving parts, and also avoid for rubbing with the sharp edges because there must be a some vibration during the vehicle running. So it should not happen after a couple of minutes running the engine. Sharp edge get penetrate in the hose and hose will leakage. So then engine will fail. So these all critical points need to be take care. Do not open filler cap. Coolant capacity of entire system is approx 3.2 liter. And keep fins for the radiator free from must. So once the vehicle is on road, there must be a mud, water places on the radiator system. So if fins get choke up, then performance will deteriorate. So it's a serviceable point, but it's a general information for the automotive use. So now we'll go for the fuel system. Since it's a bi-fuel system, so there is a two kind of fuel we are using. So second one is only for the limp form. So port fuel will be the CNG or HCNG, and limp form means if gas empty from our vehicle, then we can send the vehicle up to the filling station through secondary fuel. So we call it as a limp form fuel mode. This is a gasoline in our case. There is a few components required for this fuel line system of gasoline. So fuel line, fuel tank, and pump. So this is the overall layout of the fuel test system. So this is a sheet metal tank for the gasoline, means petrol, and then outlet. Then there is a filter, then fuel pump. If there is a gravity fuel feed system, then pump must not be required. But in our case, we have a bi-fuel vehicle, so we must use either pump or either solenoid valve. So we can use only one fuel at a time. So when vehicle is running in CNG, we must stop the fuel supply. So there is a cutoff valve as a pump or as a solenoid we can use to cut off the fuel, CNG to gas or gas to CNG. So this is a gasoline layout: fuel tank, fuel filter, fuel pump, then T connector, then solenoid valve, then carburetor. This is the flow for the gasoline fuel. And this is the flow for the alternate, the core fuel, say for example CNG or LPG or HCNG. The CNG tank, then CNG tank valve, then high pressure line, then CNG regulator. CNG regulator will reduce the pressure, then low pressure line, then CNG filter, and then CNG injector. So gasoline system is a carburetor where air and petrol from Venturi premix and enter into the manifold and combustion chamber, whereas in CNG, air coming from the air filter and gas will be injected in the inlet manifold. So there is a slight difference between gas flow and petrol flow. So most probably we are using fuel pipe material is NBR, PVC, SCM. So it's a high temperature resistant and weather resistance material for the petrol and other kind of fuel flow. In our case, fuel capacity is 3 liter because there is a rule when we are using a bi-fuel vehicle and secondary fuel is a petrol or diesel. So then tank capacity for the secondary fuel is max 2.8 or 3 liter. We cannot keep more capacity of secondary fuel because when we are registered the vehicle in the certified agency, so we are registering as a CNG vehicle. This is a liquid fuel, so there is a rules for tank capacity. So you have to ensure once during the integration, so fuel line should not be blocked. You can pass the air properly before connecting with the engine, pump, and carburetors. And all rubber pipe joints properly clamped, should not be any leakages. Follow fuel filter arrow direction. There is a arrow direction in the fuel filter for inlet and outlet. So must be ensure which point is inlet, which point is outlet. Again, fuel line routing to be ensured. It should not be away from sharp edge, moving parts and hot spots. So for this fuel line, radiator line, and wiring harness. So this is all rubber component, electrical part. You have to ensure it should not be nearby hot part. It should not be fouling with the sharp edges. It should not be nearby of the moving parts. So these main 3 topics you have to ensure during the packaging of the vehicle. Then electrical system. So this is a, since we are using a BS6 engine, there must be electrical devices on the vehicle. So for example, T-map sensor, injector, temperature sensor, fuel level sensor. So this kind of electrical devices we should use during our vehicle packaging. So wiring harness front, wiring harness rear. We are using a separate wiring harness for the front portion and rear portion. So same we can use on the hBAJA vehicle. Fuel changeover switch, instrument cluster, vehicle speed sensor, and clutch switch assembly. So wiring harness should be fixed away from the direct heating of engine, as already we have discussed. So during the connection of battery and wiring harness, so you must ensure first we have to connect battery positive terminal with the electrical system and properly tied positive terminal, and then we should connect ground terminal. What happen if you connect first negative, then if we have a chassis ground system, there is a concept chassis ground. Chassis ground means directly we provide ground cable from battery to chassis frame. So anywhere we are locating any component, that component require ground, we can take ground cable from chassis to component. So there should not be any required long length of ground cable from battery to component. So for this concept, many places they are using ground as a chassis frame. So in that case, you connect ground cable with the positive negative terminal first, then you try to tighten positive cable, and by chance if spanner or any electrical or metal component touch to chassis frame, and it will get a spark or fire. So always we have to remember, first we have to connect positive terminal with the battery, and last negative terminal for the battery. If we want to disconnect the system from vehicle or from battery, then must be first disconnect negative terminal, and last we have disconnect positive terminal. So this need to be ensured during the electrical connection with battery and harness. Ensure proper coupler is insertion in proper component, otherwise component or wiring harness can damage or misbehave. Battery voltage should be maintained 12 volt. Apply petroleum jelly on the battery terminal for preventing oxidation and any other problems for the connection. So petroleum jelly we should apply during after connection for battery positive and negative terminal to avoid atmosphere effect. So this is a general sketch and photograph of actual three-wheelers, how we are clamping the wiring harness with the chassis frame. So you can have a look. This is a relay box. So location of engine component, you need to package as per your chassis structure. There is a both side lug to open the relay box, and screen printed the information on the cover, which relay, which location used for what. So this is the instruction, informative instruction. There is a fuse box having a different kind of fuse, having 10 ampere, 7.5 ampere, 20 ampere. Different fuse have a different function. So function is also mentioned with according to with respect to fuse numbers. There is a extra fuse provision in the cover. So immediately if something happen and fuse gets failed, so for the one time we can use spare fuse for immediate solution. So now we'll go electrical connections. This is more about wiring harness connected to the engine and electrical devices. Connection of electrical electronic instrument equipment to the wiring harness is one of the critical area possibility from where it can misbehave, malfunction, and stop working easily if we are not connect properly. In general, electronic connection are secure with the seal and locking mechanism in order to prevent against accumulation of water, dust, and any other foreign particles and loosening of the connection. So there must be a positive locking provision in all connection with the component. So here we highlighted red sign and green sign. red side means push type connector, green sign means pull type connector. So when you connect or disconnect any kind of coupler, you have to see which kind of locking mechanism provided for that connector. Never pull the coupler from the wire. You should hold the entire socket for disconnection and connection. Never pull the coupler without releasing locking mechanism. Never remove modified seal or coupler. So this is yellow color part is a sealing. We call the sealed coupler. So it can protect water and foreign particles enter the between terminals. Never connect any coupler while ignition key is on. So as I said earlier, whenever we doing the work for the electrical system, we must ensure and check whether electrical system is on or off. So if we want any connection or disconnection from any device, we must off ignition switch before the remove of coupler at any location. And one most critical thing is this is a program based vehicle. So there is a brain. We are operating through 5 volts and there is a microchip. So never connect ECU. We call electrical control unit. ECU is a programmable unit and program will be flashed as per the calibration. So this device disconnect connection, battery is connected. So never disconnect this unit while battery is connected. First we have to disconnect the battery and then we have to disconnect the device or connect the device with the wiring harness. So this is a different kind of coupler and component name. Which type of locking mechanism is there? See, for red signal means push type connector. So you have to push for the connection and you have to press something for disconnection. This is for low pressure filter and sequence mentioned how to operate connection and disconnection. This is a sequence mentioned. This is a pull type connector. So you must have to pull something for connection and disconnection with the matching parts. So once you go through the detail, once you get the presentation at your end, so be careful during the packaging of this vehicle. Again, pull type connector. This is a temperature manifold absolute pressure sensor. Pull type connector for CNG injector. Pull type connector. Throttle position sensor. It's a pull type connector. Connection and disconnection both process we are mentioned. There is a alternate coupler disconnection for RR unit. This device is required for the battery charging. Here a click sound mentioned here. So when you connect both coupler, you feel the sound click. So you ensure that coupler is properly connected with each other. Pull type connector. So in this case, you have to also ensure there must be a pokai, okay, because male and female part need to match. Then only coupler can connect properly. Otherwise, it will not enter into each other. Ignition coil coupler is a push type connector. Connection. Oil pressure switch. There is a terminal type connector. You have to use specific size of spanner and for the connection and disconnection of oil pressure switch connection. There is a ring terminal and screw arrangement. So here we have mentioned a guideline for the ECU coupler disconnection. So first we have to, as we discussed earlier, during the operation, during the connection, we have to use first positive and last negative. During the disconnection, we have to first disconnect negative. So same thing we have mentioned in this presentation. There is a specific locking arrangement. This is called ECU, electronic control unit. So all signals coming to this ECU, this program sending signals to the actuator. This is a vice versa. Both communication will be done through this device for the engine performance. So this function most probably you will get understand once you feel the parts in your hand. This is a idle air control coupler, the push type connector. It's a vehicle speed sensor, push type connector. So we have mentioned all the information how to connect and disconnect about wiring harness. Push type connector, CNG solenoid coupler, pull type connector, coolant temperature sensor, push type connector, petrol solenoid coupler, push type connector, oxygen sensor. This is the one more important coupler. This coupler having both of the function for the disconnection. You have to push and pull. Then you will able to disconnect the coupler from the mating parts. So here if you can see the red portion mentioned here, which is color black, you have to push this portion and then pull this gray portion towards back side. Then only we are able to disconnect this coupler from the mating parts. So this is a push and pull type. Both function is there in this kind of connector. This is specifically for the oxygen sensor coupler. This is the most critical part for the emission point of view. Pulsar coil coupler is a push type connector. This is called instrument cluster. So this will indicate to the rider how probably our vehicles are moved. So we can see speed, battery indication, oil pressure, malfunction indication lamp. If there is a error in the system, then MIL lamp will glow. So we can diagnose which kind of problem happened in the system. We can do this diagnosis tool. This is again gas indication. In the gas indication in our system, there is a 5 LED. So 4 for green LED, 1 for red LED. Red is for reserve and green for 1/4, 3/4, half and full. There is a engine overheat light will glow only if engine coolant temperature is 103 degree Celsius. So there is an indication and warning lamp. If something happened in the engine system and engine system temperature is not under control, and after certain temperature, the indication will glow and indicate to the rider there is a problem in the system. So we can diagnose and resolve through this information. This is a fuel mode selector switch. So selector means as we have discussed, we have a dual bi-fuel vehicle. So we can run the vehicle on either petrol, either on the gas. So this is a selector switch. If we want to run the gas mode, then we have to press upside. If we want to running in petrol mode, then we have to press bottom side. So this will disconnect cutoff switch for gas and petrol mode. This operate on the 12 volt and working temperature is minus 30 degree to 85 degree Celsius. And these components will be supplied by Advantage system. This is a clutch switch. So in our case, this is using most probably for three-wheeler to protect the starter motor. So if vehicle is in gear and somebody wants to crank the engine, so sometimes what happen, this kind of commercial vehicle, driver not follow the rules and regulation for the vehicle operating system. They will crank the engine along with the gearbox and travel with the starter motor from one place to other place for 1 feet or 1 meter or 2 meter. In this case, starter motor will burn or loss of function. To protect this phenomena, there is a clutch switch device applied to the system. So whenever you want to start the engine, you must push to clutch, so power will not transmit to the gearbox. So there is a no additional load on the starter motor or engine. So that's why this device is provided to protect the starter motor. This is a starter protection logic. This is program in the ECU. So in case of successful attempt to start the vehicle, turn off the ignition key and wait for 5 seconds for next attempt to start the vehicle. Maximum 5 cranking attempts are allowed at a time, and for next cranking, turn off the ignition key and turn on. So if you attempt starter motor function to start the engine, so you can attempt only 5 times. After that, you have to compulsory off the ignition switch, wait for few seconds, and again we can attempt for the engine starting. So it will protect starter motor function. So if this logic is not there and you are continuously keeping the cranking, then starter motor can burn. And no cranking allowed if engine is running. So there must be a mechanical connection between two gears. So if engine is running and you push start the starter motor button mistakenly, then crash between two gears. To avoid this phenomena, there is a starter protection logic, and cranking will not be allowed once engine is running. Also, there is a provision through micro switch, and micro switch is located near the fuel filling nozzle on the cylinder valve. So if we are filling the gas in the system, there must be a we have to remove one piston type of nipple from the first stage regulator, and nipple is connected with the micro switch. If when we remove this nipple, micro switch will get operated and sent to signal ECU. So ECU will not supply the power to the starter motor. So once you fill the gas, remove the gas station nozzle, and again we put the same pin, and micro switch will disconnect and send signal to the ECU. Now gas filling operation is completed. So then ECU will allow to crank the engine. This is a starter motor safety protection and also for the safety at filling station. So this is the last slide about the tools and fastener. It's just general basic information. So whenever you package the vehicle, during packing this kind of tools you must have for the workshop. This is a general tool ring fix. This is a clamping plier for the cooling system, Allen fasteners. This is for different kind of pliers, screwdriver. This is a specific instrument. There is a problem in electrical system. You can diagnose this to clamp meter and multimeter. The continuity is coming or not. A resistance, if any short circuit is there or not. This is a primary diagnosis tool which is available with the component supplier. I think maybe you have required during packaging or not. I don't know. BAJA SAV team will let you know. It is mandatory during the packaging or during the workshop. All OEMs bring their tool at the site, and we can diagnose the system. This is a diagnosis tool. If there is any error, we can diagnose which kind of function is not working. This is for oil filter replacement. and general tools. This is general information, types of nut and bolt. So there is a many kind of nuts are available for the packaging, and this is a bolt. The standard practice for the bolt is X bolt, and there is a mention some numbers on the head. So this number indicates the strength of bolt. Say for example, here indicated 8. So there is a 8 means the 800 megapascal tensile strength. If there is an indication of 10.9 and 10,000 megapascal strength of material, tensile strength of material. So this is indicating standard grade material. It will be selected based on the components where we have to use which length and size of fastener. So this is a basic guidelines, and there is a standard torque table grade. What should be the torque can withstand that fastener in general hardness of that material. This is a general table for the grade, tensile strength and hardness. So this is all about the vehicle integration. So all students will get this presentation to go in detail, read carefully. Okay. If there is a question, let me know after going this presentation, and if still you have a question, contact me. I will be available on WhatsApp. Okay. Thank you, Baha SAE. Yes, I am stop sharing.
Yeah, let us wait for some questions used by.
Yes.
Thank you,
So now
sir.
we,
Thank you
yeah,
so much. Thank you for the session. Now I'll proceed with the Q&A. Some questions that we are equipped with are: first, how can we extend the radiator connections for mounting of radiator in front of the vehicle?
In radiator system, we have to ensure there must be a airflow, sufficient airflow available for the fan, and fan will throw the air, and hot air should escape towards environment. So fan shape, fan face will be towards the engine side, and open face should be the environment side. So this need to be ensured during the packaging. Sufficient airflow required to the cooling system during the packaging.
Okay, sir. Second question is, how should radiator fin structure be protected? Are we supposed to cover the fin side of the radiator with any kind of steel mesh to avoid the damage to the fin structure?
Yes, it's a depend on packaging, where you package the radiator system. If you want to package the system from any external heatings, you can add wire mesh on the open side fins to protect from small stones and other foreign particles. Because there must be a chance if we running the vehicle, so foreign particles only may uh, hit to the our vehicle from sides, not from the front or bottom side. If two vehicles running parallelly and something stone or coming to the adjacent vehicle under the tire, so that stone can throw to the our side of the vehicle. In that case, protection must be required. But if our radiator face is front side or back side, then maybe a less chance of hitting foreign particles. Still, if anybody want to protect the fins, they can add wire mesh. Wire mesh is the best solution to protect the fins.
Okay, so the third question is, how much clearance should be present between wiring harness and the moving parts?
Minimum 75 mm clearance required between moving parts and hot parts.
Okay, next question is, are there any specific guidelines that should be followed for the radiator assembly in the Baha vehicles?
Yes. There is a rule book from the Baha SAE India committee, and all guidelines is mentioned and in the rule book. And also we need to follow this step-by-step procedure for the radiator system.
Okay, sir. Last question is, what precautions should be taken before deciding battery mounting and the radiator mounting?
So as we said, the battery system, battery you have to mount away from the heat and moving parts, and same anywhere you can place the battery, but you have to ensure that there should not be nearby hotted part there, and also you have to maintain the center of gravity of the vehicle. So if you mount all the component at one side, then vehicle will not be properly balanced. So according to available space for the packaging, you have to manage the weight balance and this critical points like moving parts and hot parts. So this is the 2-3 parameters you have to ensure during the packaging.
Okay, so one more question, please. How much distance is required between the heating component?
Minimum 200 mm required to avoid the direct heat transfer to the adjacent parts from the exhaust tube or from the cylinder head, from the muffler. So these are topmost 3 parts which have a more heating.
Okay, sir. So that was it for the Q&A session. Thank you so much for sharing your expertise on vehicle packaging and integration. Your insights on the challenges and the solutions in this areas are incredible and valuable to our work. Thank you, sir. Thank you so much.
Yeah, thank you, and all the best to the all the team members who are participating in this hBAJA event. Thank you.
As we move forward with our event, I request all of the teams to be present here.
Nani, sorry to interrupt you. So, you sir, there is one more question. I think it just came right now. So, like a team is asking if we use heat shield, can they have a clearance of 100 mm between the heating components?
Yes, it is possible. If we add heat shield between two surfaces on the hot surface, and it is possible to maintain within 100 mm.
Okay. I guess that's it. So, Nani, we can proceed.
Okay, so I want to inform all of the teams that we are canceling this short break. So I request you to be on the deck and be with this seminar for some more time since till the lunch break. So we'll be moving forward with the session number 3 for today. That is regulatory framework and safety requirements for natural gas vehicles. So it basically focuses on that, and we are privileged to have Dr. KC Vora with us, the advisor from BAJA SA India today, with his deep understanding of safety standards and regulatory requirements that will guide us through the essential protocols for ensuring the safe operations of natural gas vehicles. So, stage is yours, sir.
Thank you, Pawnee. Let me share my slides. Are you able to see the slides?
Yes, sir.
Okay, so you are able to see me and you are able to hear me, correct?
Yes, sir.
Okay, good. So good afternoon, friends. Today I'm going to speak on a new topic, regulatory framework and safety requirement for CNG, HCNG vehicle. So whenever we use gaseous fuel like CNG, LNG, hydrogen, LPG, we have some fear in our mind that whether the vehicle will catch fire, right? You must have seen when CNG was introduced long back in India, especially it started from Delhi, there were a lot of fire cases. You must have also seen that when electric vehicles were introduced in India, there were cases, and the cases are still going on. You can see those electric vehicles catching fire, not only in India, but in many countries, because we don't have a very good management system, a battery management system, or a thermal management system, or we misuse. Sometimes we overcharge, sometimes we keep it on charge throughout the night, and so on. So whether it is a mobile, whether it is a laptop, or whether it's an electric vehicle, you need to charge limited. If you charge throughout the night, it can catch fire. Similarly, when it comes to hydrogen, hydrogen is colorless, odorless, and you can't see even if it leaks, you can't smell it if it is leaking. And even if it catches fire alone, individually hydrogen, then you cannot even see the flame. Yes, when hydrogen touches any particular object and that object is under fire, then you will be able to see the fire. Till then, you will not be able to see the fire. So there is always a risk associated with any technology. We will have to be very careful. But I must also tell you, मैं आपको डरा नहीं रहा हूँ, आपको I must also tell you that a lot of research has been done where it says that if you add 18% hydrogen in CNG, it is equivalent to that of CNG. It is much safer. The property also does not change a lot. But our idea is to slowly introduce hydrogen into it and increase the content of hydrogen in this HCNG so that we get used to it, and one day we will be able to use 100% hydrogen. That is what is the aim of this year. Also, the aim of this hBAJA event is that you learn the technology. By the time you participate in this event and pass out, automotive industry will require a lot of people who are good in alternate fuels, in hydrogen as a fuel, fuel cell, and so on. So like electric vehicle, there would be a parallel technology and parallel type of people required. So some people who are already working on engine can be reskilled in this area, but you have a choice to be an expert in EV or to be an expert in alternate fuel like hydrogen and HCl. So with this background, we have to be careful, and hence Government of India have standardization agency like BIS, Bureau of Indian Standard, who take care of all the requirements related to standardization of fuel, standardization of how that fuel is used in the vehicle, storage of fuel, and so on. So there are various standards. Since CNG was introduced before 2 decades in India, there were already standards laid down. So we will talk about the standards which are laid down for use of CNG in a vehicle, which would be similar to the use of SCNG with 18% hydrogen in the vehicle. So it is wiser that we study standard related to CNG and then work more towards HCNG. Let me change the slide. Yeah. So there are 2 standards, AIS 024 and AIS 028. Now, what is this AIS? AIS stands for Automotive Industry Standard. Since BIS, Bureau of Indian Standard, works on all the standards of various products and processes across India, it is difficult for them to develop standards so fast. So a special work has been given by automotive industry and Ministry of Heavy Industry to ARAI and similar टेस्ट एजेंसी कि आप ये स्टैंडर्ड बनाओ, क्योंकि आप तो दिन रात ऑटोमोबाइल पे ही काम करते रहते हो और आप ऑटोमोबाइल इंडस्ट्री और ऑटोमोबाइल कंपोनेंट इंडस्ट्री को भी सपोर्ट में लो और साथ में मिलके एक स्टैंडर्ड बनाओ जो इवेंचुअली BIS विल implement it. So initial standards are made through a group of people, a committee called AIS Committee, Automotive Industry Standard Committee, which is where the secretariat is at ARAI. And this committee formulates various standards. Up till now, they have formulated 200 and more standards related to automotive application. And then they send it to BIS, and BIS at their own leisure will convert them into BIS standards. So today we are going to talk of 2 AIS standards, Automotive Industry Standard 024 and 028. Now these standards are related to safety and procedural requirement for type approval of gaseous fuel vehicle and also code of practice for use of gaseous fuels in IC engine. So we will be talking in detail about these 2 standards. Now, the next question which will come to you in your mind is, where are these standards? How do I find this standard? So if you are participating in BAJA, Supra, or any competition which are related to automobiles, then you can go to ARA website, www.araiindia.com. I will write that down here so that you guys can see it properly. www.araiindia.com. Fine. ARAI India. So there are two I's in the center and okay. Let me save this. Okay, so go to ARI website, www.ariindia.com and search for AI standards, and then, or you can directly search for AI 024, AI 028, and you can download these standards free of charge. Not only this standard, there are more than 200 standards. You can download all of them and study them and find out which one are useful to you, which one are useful to BAHA, and so on. In all our rule book, we have, at the end of the rule book, we have written series of AI standards, which are more related to your event, right? So with this background, let us start writing about understanding about AI 028 and AI 028. So the actual name of the standard of AI 028 is called Safety and Procedure Requirement for Type Approval of CNG, Bio-CNG, LNG operated vehicle, right? So CNG can be something which is produced by from the earth surface, like Bombay High, or you can use biogas to produce this CNG, or you can use natural gas, and all these are same form, basically methane, which are used as a fuel. And it can be used as dedicated, that is, the vehicle will have only CNG, or it can be biofuel. When I say biofuel, there will be a 5 liter or a 3 liter petrol tank. So in case CNG fuel gets exhausted, then you can use petrol. So the vehicle has to run in petrol and CNG mode. So there will be a switch which you can use. If you want to run it in petrol mode, use this part of the switch. And if you want to use in CNG mode, then use this part of the switch. So you can toggle that switch, right? Now, why do we do that? Because there is a possibility that CNG is not readily available across the country like what petrol is available. So there may be limited petrol pumps, and there may be a big queue of CNG. Sometimes when you go LPG and CNG, there may be a big queue. And if you don't have patience, you don't have time, and you don't want to wait in the queue and you want to move on, then you can use petrol. So there was a time when we introduced CNG and LPG were much cheaper than petrol. Now the cost of CNG, LPG are increasing day by day along with petrol and diesel, and they are a bit, I think, 10 rupees cheaper than gasoline. So that charm of using low cost fuel is gone. But there are certain advantages and disadvantages, which we will see in the subsequent slide. Now, these standards have 10 annexures. So beside the standard, there are 10 annexures, and this may keep on getting updated. So when you download the AI standard, you must also download the updated version or the corrections which are done regularly related to any standard. So these are the 1, 2, 3, 4, 5, 6, and 7, 8, 9, 10. These are the 10 annexures to these standards, which talks about what is the technical specification of the fuel, what should be the technical specification of the vehicle, how the vehicle has to be specified, what is the checklist to check the fitness. So the checklist is similar to a technical inspector's checklist. Maybe you can download them. What are the safety checks required? What are the criteria to authorize the kits? So if you are retrofitting a kit, you are removing the petrol engine and putting a kit, or you are just removing the carburetor and putting a kit, CNG kit, then what should be the procedure to authorize the retrofitting of this CNG kit? Installation certificate. So what type of certificate we will give? Checklist for the third party inspection for built up CNG, Bio-CNG and LNG buses. Checklist for preventive maintenance for in-use CNG, checklist for third-party checking for new vehicles or retrofitted vehicle before registration, and the test to be carried out by test agency on CNG, Bio-CNG, LNG vehicle. These are the 10 annexures. We will directly, indirectly talk about some of the annexures. Then comes AI 028, which is the code of practice for you. So when you are using CNG or any gaseous fuel, then what are the code of practice? What care you must take? That is also mentioned. So if you compare gasoline and CNG, you will see that CNG is a high octane number, so it can give more better performance, but it requires a higher compression ratio. But if you are going to use a bi-fuel engine, that means petrol or a CNG one at a time, then you cannot increase the compression ratio to suit CNG. Hence, you have to sacrifice 10% of the power. On the contrary, if you shift from gasoline to CNG. But if I increase the compression ratio, then I can 100% utilize the CNG performance. But when you switch back to the petrol mode or the gasoline mode, there would be knocking. To ensure that there is no knocking, we don't increase the compression ratio in a bi-fuel engine, and we manage with 10% lower performance. So if you are going to use CNG without change of compression ratio, which you would do, then your performance will go down slightly. However, if you use a dedicated CNG, which don't recommend that, and it is not allowed in BAHA, but there are certain vehicles which use dedicated CNG, that is no gasoline tank at all, or there may be a 3 liter or 5 liter gasoline tank, but not recommended because the knocking will take place. You can increase the compression ratio and use it. The flammability limit also is high. The flame propagation speed is low, and because of which CNG is more safer than gasoline. आपने हिंदी पिक्चर में देखा होगा कि वो विलन या हीरो एक दिया सलाई या एक मैच स्टिक जलाता है, पूरी गाड़ी बस्ट हो जाती है. Such vehicles have to be petrol engine. Diesel doesn't. His diesel flammability is not so good compared to that of gasoline. But CNG is much safer. It just cannot catch fire even if it leaks. However, the density of CNG is less. So, जो आप पेट्रोल टैंक में जो पेट्रोल डालोगे, अगर CNG में वही अगर विदाउट एनी प्रेशर डालोगे तो बहुत कम CNG आएगा, because of which your range will reduce. So you need to increase the pressure of storage of CNG. And as on today, we are using 200 bar as the pressure for storage of CNG so that we can have a better range. But when it comes to hCNG, the pressure can be increased to 250, 300, 350. And in some cases abroad, they are also using 700 bar for hydrogen, right? So that means we need a stronger cylinder to store this in case we use higher pressure. So in our case, when we are talking about hCNG, we may still use 200 bar or 250 bar and not more. So we don't have to worry about the cylinder, but still we are trying to work on cylinder which is more stronger. So there are 4 types of cylinder: type 1, type 2, type 3, type 4, which Ajit Babu will let you know, in which type 4 cylinder is the safest of all. And if you use 100% hydrogen, you have to positively use type 4 cylinder. Since we are not using 100% hydrogen, we are comparatively safer, right? So also, as I told you, gasoline has an odor, but CNG, like hydrogen, is odorless and colorless. So you would not come to know even if it leaks. Okay. So this is the entire circuit schematic diagram of a CNG kit installation on the vehicle. So you will see the engine. I'll put the cursor there. You can see the engine here. And there would be an exhaust after treatment like catalytic converter. But when we supply the engine to you, when you will buy the engine from Greaves, catalytic converter will not be fitted because we want you to experiment on the Go Green event. And this is a CNG injected engine where the CNG will be injected. And in case hCNG is injected, it will be an hCNG injected engine. That means 18% hydrogen will be pre-mixed at the gas station or at the casket. And when you go for your refill or fill of the hCNG, you will not find any difference between like what you fill CNG and what you fill hCNG because it is pre-mixed. And then it is injected. So the CNG tank will have 200 bar or CNG or 200 or 250 bar hCNG. All other things remaining same. So in old days, we were using a gas-air mixture. So when the air passes through the venturi like a carburetor, and through the holes, the gas, CNG gas will pass, and then they will mix thoroughly and then get into the combustion chamber and burn. When it comes to injection of CNG, we don't require the mixture. We just require an injection which will inject CNG. In case we use petrol, then the petrol will be still carbureted, and then this CNG will mix. CNG will be injected just before the combustion chamber. It's called port injection in case of grease engine. And this fuel will mix with the air and then enter the combustion chamber and burn so that the combustion is better, right? Okay, so that's the schematic diagram. And now we start looking at different components, which has been directly, indirectly explained to you, but I will be explaining from the framework, legislative framework point of view. So we require a cylinder which needs to be approved by PESO, and the CNG is stored at 200 bar. Then we require a cylinder wall and maybe a cover of the cylinder bar so that the wall does not get damaged. And this also needs to be approved as per IS 3224 as per the gas cylinder rules. Then there is a solenoid valve to allow flow of gas from the cylinder to the downstream system. That means from cylinder to the pipe to the fuel injector, and a pressure regulator to reduce the pressure from say 200 to 100 and maybe from 100 to 10 bar or 2 bar or whatever it is, right? So you can reduce it in 3 stage or 2 stage as per the required. And this pressure regulator are tested as per ISO 15500. Okay. Then there are high pressure tube, which takes the fuel, the CNG, from one place to another. Then this, when the CNG moves from the cylinder to the regulator, pressure regulator, it is still at 200 bar. So those pipes also must be very strong, and it must be tested not at 200 bar, but at 700 bar as per IS 15716. Then there are low pressure flexible tube also, that after the pressure is reduced and then it goes to the injector, it is less risky, but the standard is 15722. As far as the CNG cylinders are concerned, you will see a cylinder below the driver seat, or in the rear of the vehicle, in the luggage compartment, or it can be below the engine in case of BAHA, in the rear of the vehicle. So such cylinders also needs to be certified by PESO, and it has to be checked for corrosion. It has to be checked whether the cylinder is securely mounted to the vehicle with the help of those straps and the hardware. And if the tank is mounted on the floor, the thickness of the reinforcement shall not be less than 2.5 mm. There should be rubber padding. There should be clearance of minimum 5 mm between the tank and the vehicle on left side, right side, or either side except the floor. The clearance between the tank wall and the vehicle body should be 200 mm. The material of the padding lining provided for inner side of the cylinder mounting band is of EPDM, so it's like a rubber type material. Okay. Then the cylinder valve, the check specific valve and model approved by the vehicle testing agency. So there may be different makes, there may be different manufacturers. So the valve manufacturer may be different and the cylinder manufacturer may be different. And one of the party will assemble them together and sell it to you. So you check for its operation, check for its shield. That means there has to be a shield in case of an impact. The first shield will damage and then the valve will be saved. Then check whether there is any damage to the valve at the time of fitment, right? And check for the burst disc. So there is a test, burst test, leak test, all those things have to be done, right? Okay. Then there are refilling valves. So when you are refilling your fuel from a CNG casket or a CNG gas station to your vehicle, then there are certain valves used. So these are those CNG relief valve, refilling valve. So you need to check for its safety, for its position, whether the dust cap is there or not, what make it is. It must not be a spurious make, and then it must be also authorized or certified and so on. And also the leakage and the non-corrosive foaming agent has to be, using a non-corrosive foaming agent, you can check for the leakage. Okay. Then the fuel lines, the pipelines, the high pressure pipeline, the low pressure pipeline, whether there is any leakage there or not. Check the U and pigtail bends provided in high pressure for flexibility. Distance between two clips shall not be more than, so at every 500 mm, you can fit a U clip, and the distance between fuel line and the exhaust pipe should be away. So please ensure all these fuel lines where CNG is passing must be away from the exhaust line, right? Or you can use a heat shield in between. Okay. Then we talk about the regulator, which reduces the pressure from 200 bar to a lower to atmospheric. It can do it in 2-stage or 3-stage, and we need to check how it works, right? And here also that this it should be away from the exhaust line by 100 mm. Then the gas solenoid valve, which allows supply of gas as and when required by the user. So when required, the solenoid valve opens and we use it, and otherwise it is always in closed condition. So what make it is, what date it is, all those things must be mentioned on it, and check whether the shutoff valve is securely mounted or not. Okay. Then this is a mixture. So in our case, there is no mixture. We use a fuel injector. So this is of no use to us, but it is still a part of the standard in case somebody is using a mixture. But just for your information, you can see this is a Venturi type, like a carburetor.
Boris,
Yeah.
sir, sorry to interrupt you. If you could do it in like slideshow mode, so the teams
Oh,
will
I'm
be
sorry.
able to see.
Yeah, I'm sorry. I'm sorry. Yeah, I'm sorry. I forgot. Okay. So you like a carburetor which uses a Venturi, the CNG mixture also uses a Venturi, and you will see there are small holes in this Venturi, similar to what you see on your cooking gas, where you use LPG, small holes in the burner. So the CNG will come through those small holes through the Venturi, and more the air passes, more will be the fuel passing. So using that Venturi principle, the CNG will mix with the air and then move ahead towards the combustion chamber of the engine. So this is what is how the Venturi works. But when we talk about fuel injection system, there is an ECU which will decide how much CNG needs to be injected as per the air fuel ratio. Okay, fine. And then there are various electrical wiring. So safety checks related to those electrical wiring also needs to be done, especially with respect to the battery and the terminals. And then some ducting is required for ventilation. So those ductings also need to be provided. It can be provided, the ducting can move downwards or sidewards in the firewall. Then there will be a compliance plate, which will say that who has fitted it, what is the capacity, what is the water capacity, when was this cylinder manufactured, and all those things. So this is the compliance plate for the CNG cylinder. And when the vehicle manufacturer, any vehicle manufacturer who submits their vehicle for type approval to a test agency like ARAI, ICAT, or GARC, then they will have to fill up a form, a technical specification form. So this Annexure 1 is the technical specification form, which the vehicle manufacturer fills up and submits to the test agency for type approval. So there they will have to talk about various parts and who have produced this, and what is a working pressure, and all those things needs to be done. Sometimes even the drawing needs to be supplied. So again, these are the 3-4 pages of pressure regulator, refilling valve, high pressure tubing, low pressure tubing. In case of gas mixture, the details about the gas mixture, or gas injector. Here you can see gas injector. Who is the name of the manufacturer? So for example, Advantex is the manufacturer for the gas injector, and then type and drawing and all those things, and the injector flow specifications. So all this specification the vehicle manufacturer has to supply. So it would be a good idea that you can also develop this table specification. Then we have pressure indicator, various shutoff valves, battery cutoff valves, and so on. Right. Then we talk about Annexure 4, which talks about safety check for use of the gaseous fuel in IC engine vehicle. So whether any approval has been taken for the gas cylinder, whether the cylinder is fitted properly as per AI 028, whether the cylinder shutoff valves are checked properly or not, whether the regulator is tested as per the IS standards, and so on. And then in continuation with Annexure 4, gas air mixture or injector. So in our case, it is injector, which is tested as per ISO 155007. and alternatively a test agency to verify the test certificate. So all these components, the fuel injection manufacturer like Advantex can get it certified by a test agency in advance and produce those certificates to the vehicle manufacturer. Then when the vehicle manufacturer will go for the test certification, he need not have to get the test done again because the certificate is already there. So they will only do the certification with respect to the entire vehicle testing and not all those individual components because the certificates are already submitted which have been pre-tested. Then you can talk about the various pipes and hoses and how they are tested and checked. For everything there is a standard. Then on the cylinder we need to put one CNG word if we are using CNG. Like when you fill up petrol or diesel near the fuel tank valve, you put petrol or diesel. Similarly, CNG has to be imprinted on the cylinder. And for you, we are developing special cylinder where we will say hCNG is fitted. Okay. Then we also require various firefighting equipment. So we require fire extinguisher of a special type. This will be kept near the refilling station so that when you go for refilling for your safety, there are fire extinguishers, fire buckets, and so on. Right. So in short, when you use any gaseous fuel, whether it is CNG, hCNG, or hydrogen, a lot of standards need to be studied and implicated. So here you can see that it can be petroleum rule standards, explosive rule, gas cylinder rule, static and mobile pressure vessel rules, chemical accident rule, factory rules. All these acts and regulations are there. So we generally follow European norms. So if there are European norms or ISO norms, we follow them, convert into AIS standards, and later on convert into BIS standards. So that's how we do. Now I have last few slides, last 2-3 slides, where there are new standards are being prepared. So the two new AIS standards, which also you can download, is AIS 157 and AIS 195. So AIS 157 is related to hydrogen fuel cell vehicles. We are yet to introduce fuel cell vehicles in India, but we are very sure it will get introduced. So a standard has been made by the AIS committee. And similarly, AIS 195, which are more related to hCNG, that is safety and procedural requirement for type approval of hydrogen powered vehicle. So it can be liquid hydrogen or a compressed gaseous hydrogen. So that also has been drafted, and AIS 195 was drafted last year. And then similarly, BIS declared before a couple of years hydrogen fuel quality product specification, and also cylinder for onboard storage of compressed gaseous hydrogen and hydrogen blend as a fuel for auto. So when you say hydrogen blend, it is CNG blend with CNG. So CNG with 18% hydrogen, CNG with 100% hydrogen, and so on. Sorry, CNG with 18% or 50% hydrogen. If it is 100% hydrogen, then there is no CNG in it. So these are the new standards. You can download them from a BIS website or ARI website. ARI website is free. Maybe if you want an IS standard, you have to pay to BIS, or some of the standards are available in ARI library also. The IS standards are also available in ARI library. So then there are other European standards also which has been notified recently, and from those standards AIS 157 and 195 have been generated, like type approval of in European standards for CNG and CNG blend vehicles, or gaseous hydrogen blend vehicle refueling connection device, or ECR 134 where approval of vehicles when we use hydrogen fueled vehicle, and GTR 13 when we use hydrogen and fuel cell vehicle. So these are some of the references. The one which I have made bold are the one which, if you are interested, you must read them. It would be fun reading these standards. So that's all from my side. Thank you very much for your patience hearing. In case you want to talk to me, the best method would be to send me a WhatsApp message introducing yourself, and whenever I'm free, I'll reply back to you on WhatsApp. Or you can write to me on my email ID, vorakc04@gmail.com. I look forward to interact with you and the faculty advisors. Wish you all the best for hBAJA SA India 2025. Thank you very much. If there are any questions, I'll be very happy to answer.
Thank you, sir. Thank you so much. As for now, for this Q&A session, we haven't received any questions yet.
So sorry to interrupt you, Nani. So we have received a question. So as you mentioned, the cylinder should be below the engine, or we can place it in other areas also. So I think there is some question around cylinder placements in the
Yes,
Baha.
yes. So what is the question?
As you have mentioned, the cylinder should be below the engine, or we can place it in other areas also.
You can place it in any area you want, as far as you put up in the Baha forum and take the confirmation that this is safe, right? So when we started hBAJA, we had 5-6 locations where we thought we can place the cylinder below the driver, but then if you put it below the driver, the height of the driver will increase. On the side of the driver, either side of the driver, then in case of a side impact, there would be a risk, right? So we tried all, or in the front of the driver, in the nose, we can put the cylinder. Then in the front impact, there would be a risk, or the rear of the vehicle, then in the rear impact, there would be. So we tried all those permutation combination, and finally we found that if we put the cylinder below the engine, behind the firewall, that is the safest place where you can fit the cylinder. You need to refer the rule book. You can refer the last year's hBAJA rule book where CNG is used. And very soon we will release the hBAJA rule book of 2025 where HCNG will be used. And all those you have to follow the rule book. But feel free to talk to us in case you come out with a better idea for storage of this gaseous fuel. Fine. I hope that answers the question. So just for your information, the 3 teams which participated in Baha last year, they had different positions of cylinder. So maybe you can talk to 3 teams. Rameshwar, it would be a very good idea to talk to these 3 teams from Aurangabad, Cochin and Bhimavaram and ask them whether they can nominate one person to whom the new teams can talk to, new teams can go and visit them and see their vehicle, and also ask them some question. They can be the official mentors based on their last year. I think Rameshwar himself is the alumni of Sanskara, and there are a couple of more alumni committee members. You can talk to Rameshwar in case you need any help. Rameshwar would be very happy to share you the numbers of all the 3 teams.
Thank you, sir. One more question that popped up now is, what about the unburnt HCNG process during the combustion?
Yeah, so whenever there is a combustion, some gases, some products of charge would be unburned. It would come out. It would come out as methane, right? So we generally divide hydrocarbon in 2 forms, methane and non-methane hydrocarbon. So they would come out as it comes out in petrol also, hydrocarbon would come out. And there is a catalytic converter or an after treatment device which will convert this hydrocarbon into carbon dioxide and water vapor using a catalyst, a platinum catalyst or a palladium catalyst. So when you work on Go Green, you can do a lot of research on this and work on it. But the hydrocarbon emission, that is because of some of the CNG being escaped unburned, is lower than the hydrocarbon emission, because of which some of the unburned fuel, that is the petrol gas coming out from the exhaust. So when we use CNG in compared to gasoline, we are drastically reducing carbon monoxide and hydrocarbon. NOx may remain same, or sometimes it can slightly increase also if you increase the compression ratio. If you don't increase the compression ratio for bi-fuel mode, then your NOx would be lower or maybe equal. But CNG is a cleaner fuel which will give you lower emission compared to a gasoline. Hope that answers your question.
Thank you, sir. Thank you so much for this session. And I hope for all of the teams, your expertise in this field is a great crucial point in navigating the complexities of natural gas vehicle safety. So thank you, sir. Thank you so much. We're delighted to have you on board on the stage with us. Thank you, sir.
Thank you. I will take leave now. Thanks a lot.
To all the teams, as per mentioned by Vora sir, you can visit the ARAI India website to download all the AIS standards mentioned in today's session. You can review the rule book of previous year at this year as well for all of the doubts that you're having, and you can reach out to us anytime for the doubts. Now we'll be having lunch break and we'll resume from 2:15 p.m. with our next session. So all the teams be ready at 2:15 p.m. I request all the teams to be back at 2:15 p.m. for the rest of the sessions that we are having. The next session that we'll be having is of Mr. Rahul Garg, and I hope you all will be joining for that. For now, I'll be taking leave. We'll be having a break. Good afternoon, everyone. I welcome you all back to the session after this break. So, this is the last session for today. And to conclude the session, we are having Mr. Rahul Garg with us from BPCL to discuss about H2 production. Mr. Rahul Garg, with over 15 years of experience, is currently manager of R&D at BPCL, focusing on the green hydrogen generation and alternate fuels development. He holds an MTech in Energy Sciences from IIT Delhi, where he was a DAAD scholar and was awarded Professor O.P. Gupta Medal. With prior experience at FEV Hero Motor Corp, he has an expertise in IC engine development, optimization, and alternative fuel evaluation, holding 4 patents and 4 design registrations. Mr. Garg will share his expertise on the various methods and technologies involved in the production of hydrogen, a key component in the future of clean energy. The stage is all yours, Mr. Garg.
Thank you, ma'am. Am I audible?
Yes, sir.
So I'll be sharing my content and then we can proceed ahead. My slides are visible?
Yes, sir.
Okay. Once again, a warm good afternoon to all the participants present in this call. As ma'am has already given an introduction about myself, I am working with Bharat Petroleum Corporate R&D Center, wherein I am working in the area of green hydrogen. So as my previous speakers for the yesterday also has covered about the hydrogen properties, its use in IC engines. So I'll be giving my perspective of the overall green hydrogen value chain, because as a oil and gas industry, you know that we are processing the crude, bringing it to a refinery, converting into diesel, gasoline, and then bringing it to the retail outlets, and then dispensing into the vehicles of the customer. So we cover the complete value chain. Similarly, green hydrogen also has a value chain, which I will be covering, and I will give you all the perspective. What is the behind any what is the value chain made up of? What are the aspects of each and every component of a value chain? What BPCL is doing in that value chain? And I will be imparting more of the knowledge on the terms of electrolyzer, because that is the newest technology come into the picture in globally for production of green hydrogen. So as you can see, for any green hydrogen value chain, this is a value chain wherein when we talk about green hydrogen, we should essentially have the renewable energy with us, and we should have a water with us, because we have to do the water electrolysis with the help of renewable energy. That could be solar and wind. With the power, if it is 24/7, then we have the best capacity utilization factor. When both electricity and water goes into the equipment known as electrolyzer, it breaks the water with the help of power into hydrogen and oxygen. Hydrogen being the very precious gas, we want to produce it through this electrolysis route in a very efficient way. And for producing 1 kg of hydrogen, almost 9 liters of ultra pure water is required. Then once we have produced the hydrogen from this electrolyzer, and these electrolyzers are of various types, which I will be covering in my subsequent slides. After this hydrogen is produced, this hydrogen has to be stored in some cascade, that is a cylinders. And there are different kind of cylinders classified based upon their manufacturing process. And then this hydrogen is stored in the cylinders, and also it has to be transported. Now, you know that as an oil refinery, we process our crude in Mumbai refinery, and we send that petrol and diesel to almost straight away to Delhi. That is done through pipelines. So similar way, we are exploring the way of transporting hydrogen through pipelines also. Presently, it is not possible. Till 18% the studies are being happening, and natural gas is also being transported by pipelines. Once it is so, I have covered in the value chain, I have covered the hydrogen production through the water electrolysis, hydrogen storage in the cascade, hydrogen transport through pipelines or through the tractor tube trailers, and then is the utilization. So utilization, the prominent use of hydrogen as of now is in the refineries, power sector, steel industry, and fertilizers. Refinery, we are almost producing 600 tons of hydrogen per day. That is a kind of quantum of hydrogen we produce, and we are producing presently this hydrogen through steam methane reforming process, and basically that is a gray hydrogen. However, another route could be that we can blend this hydrogen in the city gas. City gas means the PNG gas which is coming into our home. We can blend this hydrogen into the natural gas and can use it for as a cooking fuel. Also, this hydrogen, we know widely it can be used in IC engine based vehicles or fuel cell based vehicles, and also as a power backup in the DG sets. So these are the various use cases which are currently there in the green hydrogen value chain. But what is effectively required for the hydrogen ecosystem to come out in a very cost effective manner in any country? One is that you should have a electricity, that is, it could be renewable or grid, but if it is from the grid, it is not CO2 free. But if it is from renewable energy, it is perfectly green hydrogen. And your point of view is that hydrogen where it is to be used and hydrogen to be generated, they both should be near so that you don't have a transportation cost. So if all these three factors are there, this triangle gets completed and we get the hydrogen at a very cost effective price. Moving over, the colors of hydrogen. Now when we talk about colors of hydrogen, there are many colors of hydrogen, but I'll be talking mainly on these three because currently globally these are the terms being talked about. So for the knowledge of the students also, they should know that what are the prominent colors of hydrogen. So basically is we can produce hydrogen through coal also. So from coal we do the gasification in the gasifiers and we get the hydrogen, that is CO plus H2, and then you do water gas shift, you get CO2 plus H2. Then again you capture the carbon and store, then you get hydrogen, that is blue hydrogen. But if you are not capturing the carbon and you are letting the carbon dioxide go into the atmosphere, it becomes brown hydrogen if produced through coal. But if the hydrogen is produced through natural gas, through steam methane reforming, that is CH4, when it is passed through the steam in the presence of catalyst, gray hydrogen is produced, but again, which is currently we are producing in our refinery. But if we do the carbon capture, again CO2 is captured through amine based route, it can become blue hydrogen. But there are some CO2 associated with these routes. But if we are having renewable energy, that is wind and solar, couple it with the water electrolyzers, that is alkaline or PEM, and then we get completely CO2 free hydrogen, that is known as green hydrogen. So as I was talking in the previous slide, there are multiple colors of hydrogen which are talked about. So this I'll not be explaining the complete slide, but this is for your knowledge that brown hydrogen we have touched upon. There is a turquoise hydrogen when we paralyze the methane. That means in the presence of heat, we are breaking CH4 into carbon plus H2. It becomes a turquoise hydrogen. Similarly, is a gray hydrogen. Moving over, it is a blue hydrogen. When we capture any CO2, it becomes a blue hydrogen. Green hydrogen we have already touched upon. Pink hydrogen, when we use nuclear energy to break the water, is known as pink hydrogen. And there are many other colors of hydrogen. Now, so what we have already discussed the green hydrogen value chain. So this is a summary or the brief summary of the green hydrogen value chain, that you should have a renewable electricity. It goes into the electrolyzer. So we are having a hydrogen production here. This is an electrolyzer. Then after production, we are having a distribution, storage of hydrogen, and the use of that hydrogen will be called as a net zero emission scenario. So we as a country has taken a pledge to be net zero by 2070, and adoption of green hydrogen in this scenario is we have to say that it is imperative to use green hydrogen to achieve such a humongous target of net zero by 2070. So I'll briefly, I have made few slides on hydrogen production. We'll be deep diving into hydrogen production methodologies, then storage, transport, and simultaneously we'll explain the efforts of BPCL in that area. So when we talk about green hydrogen, as I understand, there are the audience, the students are there from the college, and they will be interested to know that what is the physics or what is the thermodynamics behind water electrolysis. So we know that any 1 mole of, if we see 1 mole of water will be having a 1 mole of H2 and a half a mole of O2. How it so how it happens, water electrolysis, how it happens. So this is any water which is there. We have done the experiments in our 11th 12th also. So if we supply any outside power from the battery to the water, and there are two electrodes, one negative, one positive, it becomes an electrochemical cell. So in the electrochemical cell, we have to supply the energy which overcomes the bonding, the enthalpy of formation of any molecule. So here you know that this delta H is the enthalpy of dissociation of water which is in the liquid form. This is 286 kilojoule per mole at the standard temperature conditions. Again, this is the entropy. So based on the thermodynamic law, it is delta G is equal to delta H minus T delta S, and V gives free energy. So if we supply this much of energy from the outside, we can break the water molecule. So this, since this Gibbs free energy is positive, This shows that reaction is non-spontaneous and the reaction becomes endothermic. That means we have to supply some energy from the outside, which we take it from the grid, that which I was talking about, the renewable power in the form of wind or solar power. So this Gibbs free energy is basically the essence which comes. Now, as we know, the IC engine also has a losses. So none of the system are ideally 100% efficient. So similarly is the electrolyzer. In any electrochemical cell, there are some over potentials which has to be overcome so as to get the reaction happen. Ideally, based on what I was telling you, there is a equation known as delta G is equal to minus NFE. On that basis, if you have a Gibbs free energy of 237, N is a number of 2 electrons and the Faraday constant, 1.23 volt is the actual voltage you have to apply from the battery, a DC voltage to break the water. But these are the sum of the losses which happens, like the cathode over potential. Any catalyst which is there on the cathode has its own reduction potential, and the supplied voltage has to overcome that resistance, because that catalyst is giving a resistance for the reaction to happen. Same reaction resistance happen on the anode, and there are some ohmic losses because of the membrane or the gap between the electrode. So these are the losses which are happening. Based on this, we come to the analysis that actual cell voltage required is this much. So why I'm telling you this is that electrolyzers are also similar to the IC engine, but they also have the losses similar to the IC engine. So there's the same kind of analogy, and fuel cell is a reverse of electrolyzer. So whenever in the future, when you will be reading about fuel cell, you will be also reading these graphs only. And only thing is that in the fuel cell, you supply the hydrogen, you get the voltage output. In the electrolyzer, you supply the voltage output and you get the hydrogen out of. So fuel cell and electrolyzers are reverse of each other. Now there are multiple types of electrolyzer which are being talked about. One is known as alkaline electrolyzer, another is a PEM electrolyzer, then we have the solid oxide electrolyzers and anion exchange membrane. So if someone may ask that why they are classified on different kinds of, why they are classified by different names, because they are classified same like the engine. Engine, we have a port injection, then we have a direct injection, then we have a GDI, then we have a different kind of combinations are there in the engine. Depends on the methodology of operation, supercharge, turbocharge. Similarly, alkaline electrolyzer, it is, these are classified basically on the movement of ions from one electrode to another. Another is the temperature at which these operates and the kind of purity of hydrogen they produce and the efficiency levels of these electrolyzers. So alkaline electrolyzer is the one which is globally present worldwide, commercially deployed. PEM electrolyzers are also being deployed. However, SOEC and AEM are the maturing technologies. However, their benefit is that they are very efficient as compared to the previous two one. And also you can see the movement of cations and anions are different in all the electrolyzers. So the cations and anions are moving based upon their configuration. Again, I have listed down some of the parameters. So before slide was giving the functionally or working principle of the electrolyzer. This slide gives you basically what are the parameters on which these are classified. Same like engines, these are also classified. What is their operating pressure? What is their current density? How they are responding to, because a similar kind of parameters are there in the fuel cell also. So when you think about electrolyzer, how it is big it is. So you can see they are big of this a person. So they are bigger than the height of a person. This is a person sitting and this is one stack of electrolyzer. So you can imagine that this is the size of electrolyzer which is used for producing green hydrogen. And these are the terminals which I was showing. So from these terminals, we supply the electricity, the positive and the negative of the electrolyzer, and the reaction happens. So these are multiple cells attacked in series, similar like a lithium ion battery, wherein a lithium ion battery pack has a multiple cells connected in series. Electrolyzer also has a multiple cells which are connected in series. Coming to the reaction happens, I will not go in the detail, but I'll just take a classic example of one electrolyzer cell. As you can see, this is my cathode. Now I am putting water. Water is entering from this side. As you can see, this is a water which is going, and the reaction happens on the cathode surface. When the reaction happens, it breaks into hydroxyl ions, which are the OH minus, and hydrogen gas. So hydrogen gas comes from the top, and hydroxyl ions are produced, which then moves from the membrane towards the anode side. There, these hydroxyl ions again recombine. You can see these are the hydroxyl ions. They combine to become oxygen. And here, water in the presence of electron. The electron is the electricity which we are giving from the outside. So hydrogen is released. So electrolyzer, what? So in this, from this slide, I want to show that electrolyzer is basically electrochemical cell. This is a single cell, and when these cells are connected in series, you get a cumulative hydrogen production from complete cell. Similarly, this is a PEM water electrolyzer, wherein the reaction happens in a different way. There we were sending the water on the cathode side. Here we are sending the water on the anode side. As I've told in my previous slide, it's a movement of cations and anions, but the size of the PEM electrolyzer is much compact as compared to an alkyl electrolyzer. These both, so when you go for fuel cell, it's basically a PEM fuel cell. Similarly, if you go for electrolyzer, it is a PEM electrolyzer. So these are the two technologies which we'll talk about. Then coming to SOEC, solid oxide electrolyzer. So these are the most efficient one which are there, but the problem is that they operate at a very high temperature of 700 to 1000 degrees centigrade, as you can see here. And why they are efficient? Because again, this is a Gibbs free energy equation, that if you go on increasing your temperature, your delta G requirement will come down, and effectively your the cell voltage requirement will come down. If you see, this is a graph which shows that if this is my Gibbs free energy which comes down, this is my temperature which goes up. So when we talk about basic electrolyzer component, what is a basic electrolyzer component? Any electrolyzer has multiple cells which are connected in series, which I have told you. So this is one cell. So this is a bipolar plate. Then you have a catalyst which is coated, and then we have the electrode, then you have a membrane, then you have electrode, then you have a catalyst, and then again you have a bipolar plate. So same is the arrangement for the fuel cell, which is used for the mobility in the vehicles. Same arrangement they do. Only thing is that the electrode catalyst is different. There they use platinum and iridium. Here we are using nickel. And also from the electrolyzer, the gas which comes out. So one side hydrogen will come out, one side oxygen will come out. Then they further pass to the gas separators and goes to the purification unit, that is a deoxo and the dryer. So here we get, after the deoxo and the dryer, we get the hydrogen which is almost 99.99% pure for giving into the fuel cell. And then it goes to the compression and storage for final use into the vehicle. So where do we have R&D demand in the future? So ultimately the technology is maturing and the R&D has to be done in various aspects. So here I have listed few of the areas where you as a future engineer should work upon to bring out the better electrolyzers into the world. Already many of the startups are there being founded by the young scientists and the young engineers, wherein they are working on these kind of new electrolyzers which having very high current density, very high life, low cost, high current densities, and they can operate on a very low part load also, and they have a very high durability of the stack. So in nutshell, what are the key drivers for a green hydrogen production? So we should have affordable round the clock power. So round the clock power, if it is there, energy storage, suppose it is coupled with a battery, because we know that renewable power is there 8 hours a day. What about for the rest 16 hours? So if we have a very effective energy storage, like a pumped hydro, vanadium redox flow batteries, lithium ion, there are many kind of battery chemistries which are evolving now because of the need of this energy storage. Indigenous manufacturing with the electrolyzer. These electrolyzers, as of now, they all are imported. So we should work upon developing the electrolyzers in India, manufacturing the electrolyzers in India, which will substantially bring down the cost, and also demonstration of the technologies at a commercial scale. So as an engine, we know that engine, we do a proof of concept, we do a small prototype, then we bring out with a small, big 3D printed engine, prototype engine, then we come out with bigger engines, the bigger fleet. Similarly, for the electrolyzers also, what we do is we make small systems, we prove it in the laboratory, then we go for a bigger systems. So again, you can see this is one of the typical alkaline electrolyzer which is operated for hydrogen production. What are the government push? So government is also aggressively pushing this national green hydrogen adoption in India, and they have recently launched National Green Hydrogen Mission, and our Prime Minister Shri Narendra Modi, on this 15th August also from the Red Fort talked about the green hydrogen adoption in India. So government is very serious about it, and they have outlaid almost 19,000 crore rupees for this adoption in India, for various programs like manufacturing of electrolyzers in India, doing pilot projects in India, giving it for R&D purpose. So this story has to unfold because hydrogen is a perfect carrier of energy. So what we are doing as a Bharat Petroleum, what we are doing is we have tied up with Bhabha Atomic Research Center. BERC is India's prestigious atomic energy institute, and they have developed the electrolyzer technology. This is the electrolyzer which is developed by BARC, and we are doing R&D on this product in our BPCL R&D center. This is up and running, wherein we are producing hydrogen, and we have demonstrated these electrolyzers on a higher scale to our Honorable Prime Minister also during his visit to India Energy Week Goa. We told him that we are working on this and we are confident to bring it indigenously manufactured in India. Now, this was one part of the value chain, that is hydrogen production. Due to paucity time, I'll go to the hydrogen storage. We know that once hydrogen is produced on the site, it has to be now transported. But before transported, it has to be stored. Now, either you can store it in the form of gaseous form, wherein you compress it to 350 bar, 700 bar, or 900 bar, or you liquefy it. So liquefy means, again, liquefying the hydrogen, going for further sub-zero temperatures, and you liquefy it through cryo methods, and then again cryo compressed. So again you can, so why we are doing it? Because we know that hydrogen density is very low. It is almost 0.089 kg per meter cube, which is very low. So for increasing the density, either you have to compress it or you have to liquefy it. And liquefying, either you do for a cryo or you do for cryo compress. Otherwise, you convert it into other form, which is in the liquid form. Like from hydrogen, you convert into ammonia through Haber-Bosch reaction, and ammonia is a perfect carrier. Or you do it liquid organic hydrogen carriers, and then you effectively transport from one place to another. So either you can compress the hydrogen through 350 bar, that is known as, or 700 bar at temperatures. We have to cool it also so that you increase the density. Then you liquefy the hydrogen, same one ambient pressure only, but the temperatures will go to minus 253. So producing this minus 253, you need energy. Then you can do cryo compressed. You further compress the hydrogen at minus 253 degree, and then you get more amount of hydrogen stored. But again, it requires energy for cryo as well as for compression. And then we have a slush hydrogen also, where again it is a different kind of technology which is upcoming. They go below the point below the point wherein you don't require but from minus 253 to minus 259 there is a extra amount of energy which is required to bring down to that temperature. But whenever you do any kind of hydrogen storage technology adoption or identification, these are the key parameters which needs to be kept in mind, that what will be the volumetric density, what will be my gravimetric density, how much heat I would be required, what would be the kind of material of the tank, what would be the density. These all things you have to keep in mind. So based on these, based on this, this is the most traditional one. People are compressing the hydrogen and storing it into the cylinders, and the cylinders are classified based on type 1, type 2, type 3, type 4, based on the way they are manufactured, based on the material by which they are manufactured, and based on the temperature which they can withstand. So this is the type 3, and type 4 is basically the most being most talked upon as of now, because it can store the hydrogen at 700 bar. It is the most lightest one, and all the fuel cell electric vehicle are targeting to use type 4, although the disadvantage is the cost and testing certification and the manufacturability, which is not there in India as of now. There are a few of the companies who are innovating and working on this as well, and they are coming up for sure. They are coming up with the solution in India as well. Now, what we are doing it as a BPCL. So BPCL, we are working on the metal hydride based technology, wherein we have collaborated with the IIT Bombay, and we are using the metal hydrides to store the hydrogen and also to compress the hydrogen. Now, coming to the dispensing. Dispensing is also not easy, because we as an oil and gas company, we have been doing the petrol and diesel dispensing since long, and we have the complete experience how to handle the petrol diesel coming from the refinery, coming to the petrol pump, dispensing to the vehicle. All safety standard we know, but related to hydrogen, we know that hydrogen is the most dangerous gas to handle. It has to be handled with caution, because it is having a low ignition energy, high calorific value, and it requires a very low ignition energy to take as, and any spark is there in the presence of air, it can be boo. So the hydrogen dispensing has to be with care. So we are also working on this kind of a configuration. So here you can see that whenever you have electrolyzer, you produce hydrogen, you cool it, and you store the hydrogen, and you purify the hydrogen. You compress the hydrogen to the compressor, compress the hydrogen to the pressures you want. In the typical fuel cell vehicle, the pressures as of now permitted by PESO is 350 bar. So for storing the hydrogen at 350 bar in your dispenser, you need to compress it to 500 bar. So typically diaphragm compressor is used to compress the hydrogen to 500 bar. Then you have some safety valves and the control valves which are used to control the hydrogen pressure. Then it goes to the cooler. Cooler is one thing which you guys should understand, the low temperature chiller, because hydrogen is the only gas which goes to the reverse Joule-Thomson effect. Because when the hydrogen goes into the vehicle, what happens is when it expands, instead of cooling, gets heated. So you have to cool the hydrogen so that when it goes into the vehicle tank, when it expands, it should not get heated up. So we bring it to a temperature of -40 and -20 degrees centigrade, and after that it goes into the vehicle. So this is an overall arrangement which is done at the retail outlet to dispense the hydrogen. We cannot dispense the hydrogen like that. So we compress it for a higher density, and accordingly we dispense in the vehicle. So what BPCL is doing is, BPCL is setting up a green hydrogen refueling station at Kochi Airport. Kochi Airport is India's largest airport which is having the maximum solar power. In fact, it is world's first airport which is fully powered by solar. So what we are doing, we are producing our own electrolyzer there, and we will be taking green power from the solar panels, and we will be producing almost 450 kg per day of hydrogen, which will be dispensing into the hydrogen powered vehicle, which could be a four-wheeler, truck and bus. So this, you know, that I have already covered in my previous slide, that we require electrolyzer, which is powered by the power, that is a solar. Water will be taken there, it will be compressed to 500 bar, and then it will be stored into the cascades, and from the cascades it will be dispensed into the through the dispenser, it will be going into the vehicle. And then we will be accelerating this dream of government, our prime minister also, to bring up green hydrogen in refineries, industry, for mobility, for power sector, everywhere. So this covers the complete green hydrogen value chain, starting from production. This value chain will our complete will demonstrate how we are demonstrating the green hydrogen value chain, coming from power to hydrogen production, storage, transportation, and utilization. So hydrogen utilization, I will not be covering more, but we know that the perfect example of hydrogen utilization in the mobility is in IC engines or fuel cell. IC engines, we know that is a fuel which is having highest energy to weight ratio. The calorific value is almost 3 times, 140 megajoules per kg as compared to 40 megajoules of gasoline. But the challenges comes is that it is a very high flammability range, 4% to 75%. LEL is 4%, UL is 75%. That means if if your hydrogen gas has any combination and any spark is there between these two ranges, there will be a fire. Below 4%, there is no fuel, so we will not be having fire. Below 75%, the oxygen is not there. So because it's a fuel rich, oxygen get deficient. So apart from 4% and 75%, the mixture becomes explosive, and we take all the safety measures when we do experiments in our lab. Like, we have a leak detectors, we have the flame arresters, we have the flame proof devices, and we have completely ventilated labs. So my previous speakers has already covered it, so I'll not go in the depth. But fuel cell is, yes, it is a when you use green hydrogen into a fuel cell, it becomes a zero emission vehicle. Toyota Mirai is there, which is being sold, and it is also being driven by our honorable Minister for Transport and Highways, Shri Nitin Gadkari ji. And it's a perfect vehicle which is having a fuel cell, and we know that in the fuel cell we supply the hydrogen, pure hydrogen, to anode side, and we get the power output which is used to drive the motor and then in turns the vehicle. So what BPCL is doing into the fuel cell is, again, we have taken an initiative because we know that fuel cell is made up of platinum group precious group metal, that is platinum and iridium. So we are working with PSG Coimbatore and IIT Palakkad. We are targeting a development of a 2.5 kilowatt stack with a low platinum content, so that we can reduce the cost of fuel cell system. So in nutshell, what are the challenges for hydrogen related technologies? That we should, if we go for electrolyzers, we should reduce the capital cost, and we should target increasing the efficiency of electrolyzers through improving their current densities. We should develop new materials which are more stable in India, because you know the battery lithium ion again challenges lithium, which China is talking about more, and we are not having lithium. So we should target the materials which are there in India. Again, operational flexibility of the electrolyzer should be developed, because when coupled with renewable, because our renewables are not stable, they are having a fluctuation. So electrolyzer should also be flexible enough to be getting coupled with the solar. And also, how that hydrogen production cost as of now is very costly. So we should keep on doing the demonstration, the pilot project, so that we can get more and more data on this, and we can really accelerate the adoption of hydrogen in this scenario. With this, I end my slides, and I request all to please have questions, and I will be glad to answer those questions. Thank you. Any questions, please?
For now, we are not having any questions for the Q&A session.
Hello.
Hello. For
Yes,
now,
ma'am.
we are not having any questions for Q&A session. So thank you, sir. Thank you so much for the insightful exploration of hydrogen production technologies. It's exhilarating to witness how breakthroughs in the field are charting the course towards a sustainable energy future. So thank you so much, sir.
Thank you.
Now, as we are ending this session of ours, the 2-day workshop of ours, to be more specific, I'm welcoming Mr. Bharat to deliver the vote of thanks. He's pursuing his master's at IIM Trichy right now with a distinguished career as a design engineer at Tata Technologies, and bringing with him the unique blend of technical expertise and the business acumen makes him the perfect voice to express our gratitude towards this afternoon. So please welcome him.
Yeah, thanks, Nani. So good afternoon, everyone. As we are come to the close of enriching this 2 days of hBAJA workshop, it is my great pleasure to extend a heartfelt vote of thanks to all of those who have contributed to making this workshop a resounding success. So first and foremost, I would like to express our deepest gratitude to all the esteemed speakers who have generously shared their valuable knowledge and insights to all our participants. Your expert guidance has undoubtedly equipped our students with the necessary tools and understanding excels in the hBAJA HCNG context. We are deeply thankful for your unwavering support and commitment to nurturing the next generation of engineers. A special thanks to our sponsors whose generous supports has made this workshop possible. Your contributions are vital and continued success of events like this, and we are truly grateful for your partnership with Bias India. Following that, I want to acknowledge the tremendous effort of the organizing committee and the alumni committee. Your seamless coordination, meticulous planning, and the dedication ensured that this workshop ran smoothly, allowing us all to focus on learning and growth. The tireless work behind the scenes has not gone unnoticed, and we appreciate all that you have done. To all the participants, thank you for your enthusiastic involvement and active participation over these 2 days. Your curiosity and eagerness to learn have truly made this workshop a vibrant, productive experience. So once again, thank you all for being part of this journey. Let us carry forward this knowledge we have gained and continue striving for excellence in the upcoming hBAJA event. Thank you and have a great evening.
Thank you, sir. Thank you for that. And on that note, ending this, I'm calling the head of Baha Alumni Committee, Mr. Hariharan Vikas, for delivering the closing remarks on this 2-day workshop, and him being having an extensive experience in the vehicle integration and at Mahindra Research Valley, with his background as a product design engineer at Daimler Truck Innovation Center, India, he brings a wealth of knowledge and insight to our gathering. So please welcome him on board.
Thank you, Nani, for that wonderful introduction. Hello, everybody. Good afternoon again. And yeah, thanks for attending this 2-day workshop. Hopefully, the expertise of all our speakers from the industry help you gain insights on hydrogen technology, hBAJA, and what this event would turn out to be. And yes, just to make a few announcements, our preliminary round is scheduled for the 8th of September 2024, and you'll have your presentations beginning at 10 a.m. On that day, and it will go till the end of day. Slotting for the same would be released on the BAHA India forum shortly. So requesting you to be active on your emails. Apart from that, you'll also have a quiz as our usual custom being in the preliminary round that will be held on the 6th of September uh, from 7:30 p.m. to 8 p.m. For this hBAJA category, the guidelines for the preliminary round as well as um, the handbook would be released quite soon, and all the other documents, for example, the CAD file of the engine, part range specifications, etc., will be shared to you in a while. So sit tight and wait for all the announcements which are coming your way through our emails and our social media posts. So yeah, that is all from our side. And I request everybody to switch on your cameras. We'll have a group picture and we can wrap up the event for today.
Please, everyone, switch on your cameras so that we can have this group photo of us for the end of this workshop.
So also teams, we'll also unmute all of you. So if you have any brief questions to ask, you can ask then. So after this group photo, we'll just unmute all of you and we'll do that. So just stay in a bit for a minute. Teams, what we'll do is you guys can raise your hands, whoever has any questions, and then we'll unmute you. I guess everyone has been unmuted. So anyways, you can unmute. So now if and just before unmuting, you can just raise hands so that there is, if multiple people are not speaking at a time. So yeah, you can start asking questions. Yeah, Aditya, go ahead. Aditya, yes.
So, when will the phase 1 guidelines be released?
Okay, so the phase 1 guidelines will be released in the upcoming week only. Okay, so you guys are like yesterday itself we released the dates of the phase one, the poster has also been released on social media platforms. So we'll be releasing the guidelines in this week only, in the upcoming week. You'll get a notification regarding it. So, yeah. Until then, so for the new teams, you guys can also refer to previous year's handbooks of hBAJA. So that can give you a bit of understanding of what was asked last year. But again, we'll release an official guideline this year. So that will be the final format that the teams need to follow. So besides this, okay, so Shanmukh from Amigos, yeah, so you can ask. Okay, I think so. Someone from Quattro Racing has some doubts. So yeah.
Sir, after purchasing the engine, with which fuel?
Yeah. So Saurabh sir, will you like to answer this?
In time itself, that not sure even our interaction also, that you are allowed to
Saurabh, your voice is a bit less.
How am I audible?
Yeah, now it is good.
So during our last interaction in that joint meeting with the teams, I had mentioned that you have to test only with the petrol. It will be a bi-fuel engine, and HCNG will be provided only at the event site. So all your validation and other things will be done only on petrol. You are not allowed to run on the HCNG engine at your premises or campus. Any team found doing that, and if we get to know, will not be allowed to further participate in the event.
Okay,
Okay,
thanks,
thank you,
Saurabh sir. So moving on with Sandeep from. So yeah,
Hello,
Sandeep.
sir.
Yeah.
So we are having doubt regarding the cylinders here. So this HCNG fuel will be like having two cylinders, like hydrogen different and CNG different, or it will be pre-mixed one. Like we have to purchase this new cylinder, or we have to use both the new and old cylinder.
No, so there will be a single cylinder, and information regarding that will be provided by BAHA only to you. So similar to last year, like the vendor for that will be told to the teams by BAHA itself.
Okay, sir. Thank you.
So besides this, anyone has any more questions?
Oh, hello, sir. Am I audible?
Yeah, go ahead.
Yeah, so when will we get the engine CAD model, sir? CAD model for the engine.
So for CAD model for the engine, right?
Yeah.
Yeah, so you'll be getting that very soon. So the engine isn't changing. So the engine is the same engine that was used last year, okay, from Greece. So you will be receiving that soon.
Okay, thank you.
Rudraj, I would like to add,
Yeah.
last year also we had not provided the engine for phase one because engine CAD model is an IP of the Greaves. So until the team signed the MOU, which I have also mentioned in the last meeting, the CAD model will not be shared. For phase one, you guys are supposed to refer the dimensions. Last year we had shared the engine workshop manual. Based on that, you can use your creativity and for designing the roll cage and ergonomics, everything based on that information. You guys are supposed to work around how to manufacture, like how to simulate it in the CAD. Meanwhile, we are trying to check with Greaves if they allow us, it will be shared. Otherwise, you have to work out like this till phase 1.
Okay, sir. Thank you, sir.
Any more question, guys?
Sir, am I audible?
Yeah.
Yes, sir. In the upcoming rule book for our 25 BAJA event, will there be any changes in the roll cage numbers, sir? Like in dimensions?
So as of now, we can't comment on that. We'll release a draft rule book before phase 1 only. Okay? So that the teams can refer that. So it will be it will mention a few things regarding HCNG. Okay. So yeah. But so you can go through when the draft rulebook is released. You can go through that and you can check if there are any changes per se. So yeah.
Thank you,
So
sir.
team, as we are mentioning that the engine is going to remain same, I request all of you to kindly refer last year rulebook. Every single detail about what are going to be the changes for the roll cage members, everything was mentioned clearly last year. Till phase 1, assume the same and you guys can start working on that. So please refer last year rulebook, please refer last year workshop guidelines. As and when it is going to be released, we are going to update you all. And meanwhile, please refer the last year details and work out and make yourself ready for the phase 1 presentation.
So in regards to the PPTs, I think so. This recording is already available on YouTube, right? The YouTube lives are already there, so teams can also refer that. And so yeah, the recording the teams can refer because a few of the sponsors had made their own slide deck. So the PPT we might not be sharing. We'll need to confirm with them, and only then we can comment on this. But you can refer the content of that using the recordings that are available. No, so we can't share like contact information or like LinkedIn profiles of speakers. So yeah. But again, we'll be having more and more sessions like this, like workshops like this, and through them you guys can ask whatever questions you have. And you can obviously, if you have some particular questions, you can just drop, like you can obviously contact your alumni coordinators if you have any particular doubts about whichever topic that was conducted by any speaker. So we can like get that resolved if you have any doubts. Yes. So
Yes, thank you.
yeah, so there will be a physical workshop as well. So like dates for that will be notified to the teams well in advance so that they can plan their travel itinerary. Okay, so yeah. So are there any more questions, or we can wrap up this 2-day workshop? In case, I mean, I'll repeat it once again. So considering that this year a lot of new teams are also participating in hBAJA, so don't hesitate to ask your alumni coordinators regarding anything, and we'll try to get that sorted as soon as possible. So yeah.
Okay, I think we can close the session now. Thank you all for joining.
So just before ending, I think that there was one more question regarding how many cylinders can be used. So it is up to the